Morning, guys. Yeah, Deepan, I didn't switch on the mic. That's why not audible. Now it will be audible. Okay, fine. Hope video and audio is clear. All right. So video, audio clear now. All right. Yep. So I believe you would have done averages already. I believe so. Have you? Are you done with this average? And who took it? So you're done with the average and who took it? Who handled it? All right. Oh, Vijay sir. All right then. Fine. So we shall have a formula, the extension of that average concept, and based on that we shall solve one thing. And average also ratio, mix it together, you will have certain idea. We call it as allegations, and we are going to deal with weighted averages and allegations for the first half of the day, and rest you will deal with probability. Okay, we will deal with probability. All right. So we shall start with that average. Before that, before starting that, let me ask you a silly question. 33 are there. I mean, 30, exactly speaking, 30 students are there. How many of you would be there in the class? Any idea? All right. All right then. So no problem. We shall start then. Very few are yet to join. Not a big deal. Before starting, let me ask you again a silly question based on the content which you have learnt already. Okay. Are you done with this time per distance? I hope so. You're done. Yes. Okay. Again, I told you no silly question. Okay, this is a question. 290 kilometer. So two cities are there from city A, city B. From city A, train A is starting at the speed of 55 kilometer per hour. Okay, and from city B, train B is starting towards city A at the speed of 35 kilometer per hour. Okay, train A starts at 9 a.m. and train B starts at 11 a.m. At what time they'll meet in between? In between city A and city B. Weighted average allegation done now. Oh, Siddharth. Okay, so which topic is yet to done? Probability, fine. Anything else? Solve this question. Area volume clocks not done. Anju answer 1 p.m. Will check on it. Age related problems yet to complete. Age related timetable was given. Oh, 1 minute. A simple equation. 8 problems and then probability, right? That was that would have been given in the syllabus. Simple equation, yes. Okay, okay. Then we shall go to simple equation. Not a big deal. 8 problems, simple problems done now. Siddharth, can you unmute yourself? Raise your hand. We shall talk. Unable to unmute. Yeah, you raise your hand, buddy. I'll ask you to unmute and then we shall talk. Yes.
Simple equations and age problems have been done.
Okay, who took it? Any idea?
Uh, just a second.
And the date also.
Yes, sir. Just you only took it on 4th.
Fine.
Oh, sorry. It was today's schedule, but got confused.
I don't know. Did I take it? Guys, I have a doubt. Not taken up. Siddharth, which batch do you belong to? No, I didn't take. Um, is the topic taken? Simple equations and age problems.
Yes, yes, sir. The topic has been taken.
But others are telling that it's not taken. Mm, I'm getting confused. 1 minute. Today it's simple equations.
Yes, sir. I changed my batch, so I got confused. I
No worries.
was weekday batch, but I changed to weekend batch. Uh,
Weekday
I got
batch.
confused.
Weekday
Yes, sir.
batch you belong to.
Sir?
Weekday batch. Which batch did you belong to?
Uh, June 10th, I think.
Batch number, buddy. Which batch did you belong
Uh,
to?
C2.
Oh, the previous batch. Okay, 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 fine. So you switched to the batch? No, the C3 batch. When did
Yes,
you?
sir. Uh, I think,
My voice also breaking?
yes, sir, a little bit.
Just a while, buddy. Okay, you can mute yourself, buddy. Um, it's lagging also. Uh-huh. All right, Siddharth. Not a big deal. Paklama. Okay, how about now, guys? Superb, superb. Area volume, probability, simple equations, and age yet to complete. Okay, these are the topics which are yet to complete. How about data interpretation? Not done. Okay, okay, fine, not a big deal. So we shall check with the simple equation and just a while little later. See, we will check with this question now. A, B. Train A 55 km per hour, train B 35 km per hour. So train A starts at 9 a.m. and train B starts at 11 a.m. So the relative speed concept starts only at 11 a.m. So until 9 a.m. train A, and until 11 a.m. from 9 a.m. until 11 a.m. train A alone traveling. Okay, train A is traveling for 2 hours. It would have covered until this approximately. So 55, 110 kilometers would be done, and remaining would be 180 kilometers. Okay, this 180 kilometer should be done by train A as well as train B. Now both of them are moving towards each other. We call it as a relative speed. We'll use a formula. Time taken 180 divided by, since they are moving in opposite direction, we have to add it up. It becomes 90, hence 2 hours. From 11 a.m. 2 hours later, time will be 1 p.m. I want the time taken, not time taken, at what time they would meet each other in between the cities. So in between the cities, they would meet each other at 1 p.m. That's it. You understand? Okay, so simple equations and age problems. See, simple equations is the word itself says simple. Okay, they are simple actually, but you have to frame the equation based on the data given. Okay, we used to call it as wave problems, word problems, whatever it is, right? So those questions, whatever may be the words given, whatever may be the statements given, how well you are able to model it, mathematically model it, that's where your idea lies, that's where your talent lies, your skill lies. Okay, I'll tell you how to model it. Very simple. Okay, that's why it is called as simple equations. So simple equation, there are two varieties. One is a single variable, other one is double variable. So one variable, two variables. And always remember, whenever they give you two variables, okay, they have to give you two equations or two clues. So one variable means they can give you one equation or one clue. Okay, okay, suppose two variables is given, two variables are given. In that case, there are three different varieties. They can give you two equations straight away, okay, or one equation, one clue, and both of them are clues, but that's very rare, so we'll have these two alone. Okay, two varieties, one equation, I mean two equations, that's a straight away direct question. Otherwise they can give you like this: one equation, one clue. Both of them can also be clue, but still you will definitely convert it as an equation, right? Those two clues, and that again goes to this two equation problem. So leave it, no problem. So one equation, one clue. One clue means they'll straight away give you an idea. You'll just imply the idea in the first equation, you'll get the answer. So that's how we get it. Okay, so these two are the basic ideas for simple equations. Then how do I solve it? There are plenty other variables also. So what if they give you three equations? Three equations, they have to give you three clues. Okay, three clues or three equations, or I mean three variables, three equations. They have n number of variables, n number of equations, or one equation and other numbers to be clues. They have to give you like that. Most probably you will deal with these two set only, not three equations or more. Okay, not three variables or more. Very rare case scenario. So you'll have to deal with two equations or two variables, one equation or one variable, depends. Okay, so better we'll start to solve the questions side by side. I'll give you ideas. Okay, so there are no extra ideas to be given on the concept. We can straight away solve them, but while solving I'll give you some clues to find the answer. Okay, so page number 136. Yeah, 136. Question number one, first subdivision. Okay, we shall solve it. and I'll solve certain questions and I'll give you homeworks as well. Okay. So page number 136, question number 1, first subdivision. Now, first subdivision is quite easy. I'll go with second subdivision. First subdivision, straight away you will solve for x, you'll get the answer. That's very simple. Maybe like fifth standard question, not fifth standard, seventh standard question. Okay, 2 times of x minus 1, you have it like this: 2 times of x minus 1, 3 times of 7x, or 7 times of 3x. What is that? 3 times of 7x minus 10 equals 34. See, whenever you get these kind of equation, rarely you'll get it, but still, whenever you get this kind of equation, you have to think first. Use Bodmas rule. First thing, you have to check with the Bodmas. Bodmas rule means bracket, right? First check with the bracket. Okay. So first solve the bracket. 2 times of x minus 1. No, not minus 1. It is 2. Then 3 times of 7x, that is 21x minus 10 equals to 34. All right. Then solve further. Addition, 2x plus 21x, that is 23x minus 2 minus 10 minus 12 equals 34. Bring it there. 23x is equal to 46 because 34 plus 12, right? That becomes 46. Then x is equal to 46 by 2. Sorry, 46 by 23. The answer will be 2. That's how we get it. Very silly, right? So straight away we can solve it. Third subdivision, they are in decimals. We'll solve it. Ultimately, you'll get some variable like this with decimal, and then bring the values there. You solve accordingly, you'll get the answer. Okay. You try to find the answer. Tell me the answer. First question, leave it. Homework. Third subdivision, you solve it now. Let me go to the next page. Third subdivision. No, not that. Fourth subdivision, right? Third. 0.8, 0.28. 0.8 x minus 0.28x, right? Equals to 1.16 equal 1.16 minus 0.06. Is it 0.6 or just 6? 0.6. Okay. Yeah, that's the question. Let me bring the x there. You will get it like this: 0.8x minus 0.28x, then plus 0.6x equals to 1.16. Okay. So 0.8x plus 0.6x, they are one decimal. So let me add them. So 8 plus 6 will be 1.4. Okay. So 1.4x minus 0.28x equals to 1.16. Right? So here it is nothing but 1.40. Do we have it like this? Yes. 1.4 is nothing but 1.40. And even I can add more zeros, not a big deal. But here we have got 0.28. I have to subtract them. So 40 minus 20, it will be 12, 1.12. Okay. So 1.12x equals to 1.16. That's what we have. Right? Is that a question? 0.8, 0.28, 0.2. Yes. So this is what we have. And x is equal to 1.16 divided by 1.12. So multiplying by, I'm having a certain set, right? I'll multiply by 100 and 100 because I've got two decimals. So let me have it like this. Let me multiply with 100 and 100 with numerator and denominator. So I'll get 116 by 112. Both the numbers are multiples of 4, right? Because last two digits are multiples of 4. Hence I can cut it down. That is 2 times 29 times, here 28 times. That's it. 29 by 28. We'll have it as such. Or even you can have a as a fraction. 1 by 28. Mixed fraction. This is your answer. Are you getting anything else? Or did you get this one? Have you got this one ultimately? In that case, you have it. Otherwise, copy this. Suppose if it is 4, I mean 0.24x, then the answer would have been very silly. But here the answer is 29 by 28 or 1 by 28. You get it? Okay, so you can solve the fourth subdivision. That's homework. Fifth one, I'll solve it. Okay, copy them. All right. Next one, fifth subdivision. X by 3 plus x by 2 equals x minus 4. Yes, x minus 4. How do I solve it further? Quite simple. First, we have to check with the left hand side. Here, denominators are there. I have to deal with that. The fractions are there. I have to find a common fraction, which is 3 and 2. What is the common fraction for that? Common value for that, it is 6. LCM. See, 3 and 2, if you have 3 and 2 in the denominators, you find the LCM. If you have different numbers in the denominator, you find the LCM. Why? Because you're going to convert that as a like fractions. Okay. So these x by 3 and x by 2 are not like fractions. They are unlike fractions. How do I tell whether it's a like and unlike? Like means the denominators are same. Unlike means the denominators are not same. So they are unlike fractions. I'm going to convert them in terms of like fractions by finding a common multiple for those two numbers. To make my calculation faster, let me find a least common multiple so that my calculation will be faster and easier. Right? So I'll multiply by 2 here, 2x. I'll multiply by 3 here, 3x. Or otherwise in your school, you would have learned this kind of method. You would have called it as butterfly method. This one and this one. Have you? In your school, you would have learned it like this. Okay. All right. And then this is equal to x minus 4. We shall solve it. This is 5x. And bring the 6 there. 6 into x minus 4. And this would be equal to 6x minus 24. This is 5x. Let me bring this 5x there, 24 there. So 24 equals to 6x minus 5x. Hence, I can tell that x is equal to 24. This is your answer. Yeah, Suresh, right answer. 67894, right answer. All right. So this is how we have it. Okay. Now let's solve the second subdivision. So second question, I'm sorry, second question. In second question, we have three set of equations, whereas you have got two variables with two equations. Straight away, direct questions. How do I solve it? There are three variety of methods, and three methods. I'll solve it one method, one equations. Simple. Okay. So first subdivision of the second question. This is your answer, and let me solve it here itself. Second question, first subdivision. You had first equation, right? X plus 5 equals x plus y equals 5 and x minus y equals 1. X minus y equals 1. So this is my equation number 1. This is my equation number 2. Straight away I'm going to add it. While adding, plus 5 minus 5 gets cancelled. How do I decide whether I'm adding or and subtracting? Very simple. Check with the variable. Okay. So I want to, I can, if I add, can I cancel it out? In that case, I'll go with addition. Okay. If all of them are addition, then what will I do? I'll have to subtract it. Likewise. Okay. So here I'm adding because y and minus y, they'll get cancelled. Okay. So these two fellows get cancelled. This becomes 2x and this becomes 6 because 5 plus 1 because I'm adding. Okay, then what will happen? X is equal to 3. Using that in first equation, what would I get? 3 plus y equals to 5. Then y is equal to 2. That's it. So x is equal to 3, y is equal to 2. That's a very basic equation. Okay, fundamentals of the simple equations. That's how I get it. See, two equations are there. If I want to add it up. If I want to subtract it. Okay. So here I'm just checking with the equation. There are plus y and minus y are there. So what I'm going to do, I'm going to add it up, add the two equations. So plus y minus y gets cancelled. And then solving further, I've got the value of x is equal to 3. Using that value in any of the equations, you get the answer. Even if you use the 3 here, you'll get the same answer. Okay. All right. Next subdivision. Okay. And second and third are the predominant conditions. Most probably you will get that kind of equations only, not the first kind of equation. That's very simple, right? So second and third subdivisions are the very basic uh, application of the UPSC pattern. Okay. Second subdivision. Let me go there. Hope you have copied. Second subdivision. 3x plus y equals to 4. Then 2x plus 5y equals to 7. That's my equation number 1. Equation number 2. Now, I can cancel any one of the variables. I prefer y because here it is 1, just 1. So my process will be easier if I multiply the first equation throughout by 5. Why? Because I want to cancel these two equations. Right? So, first equation multiplied by 5. I'll get like this 15x, then 5y, and then 20. Second equation, you have it as such, not a big deal with that. 2x plus 5y equals 7. I'm going to subtract them. Why I'm subtracting? These two are of same sign. I'm going to subtract it so that I'll cancel down. Okay, so subtract these two. Minus, plus 5y minus 5y, gone. 15x minus 2x will be 13x. And 20 minus 7, it will be 13. Hence x is equal to 1. I'm going to use this value anywhere in the first or second equation. Let me use it in first equation itself. That becomes 3 times of 1. 3 times of 1 plus y equals 4. So this is 3 plus y equals 4. Then y is equal to 1. That's how we get it. X is equal to 1. Y is equal to 1. Okay, you get it? Simple, right? But here you have to decide. See, you can solve these two also, but that belongs to third type. This is my second type. Third type is there. That's third subdivision. We'll solve it. So here I'm going to check with the number. This is just 1y. Here it is 5y. So if I multiply this equation throughout by 5, I can have 5y. Then I can subtract it. I'll cancel it out. I'll get only one variable in one side and the numbers in the other side. I'll solve it. I'll get x value or y value, whatever it is. Here I'm subtracting y now, so I'll get x value. I'm cancelling y, hence I'll get y value. Sorry, x value. And further, I'll use a value in any one of the equation. I'll get the answer. Simple. Okay. And we shall go to the third subdivision. 2x plus 5y equal to 5. 3x plus 2y equals to 13. That's very basic again. But here, third type. All right. So this is what we have right now. 2x plus 5y equal to 5. 3x plus 2y equals 13. Yeah, that's what we have. Now I want to cancel any one of the variables. Look at the variables. So for x it is 2 and 3. For y it is 5 and 2. I can cancel out any variables. Let me. I'll prefer x now. So far for the past two problems, I've been canceling y at the beginning at first, right? So here I'm going to cancel out x. Even I want to cancel y, I can do that also. But still, I want to find a number common for 2 and 3 for the case of x. For the case of y, I want to find a common term, LCM of 5 and 2. Similarly for the case of x. So let me have LCM of 2 and 3 is 6, no? So I'm going to multiply that. Okay, so I want to convert a number, this one, to be 6. Multiply with 3. So that this fellow becomes 6x plus 15y equals 15. Then second equation multiplied by 2. So that you will get 6x here. 6x plus 4y equals to 26. Subtraction. You're going to subtract them. 15 minus 4. It will be 11y. If you subtract it, you'll get minus 11 because this will be minus, right? 15 minus 26 will be minus 11. Then y is equal to minus 1. So bring it here. You'll divide it. Minus 11 by 11. Thank you. Minus 11 by 11. It will be minus 1. I'll bring the value anyone. I'll use the value anywhere else in the first or second equation. Let me use that in first equation. No, second equation for this case. 3x plus 2 times of minus 1 equals 13, right? So 3x, that becomes minus 2, 13. 3x equals to 15, then x is equal to 5. Hence the values are x is equal to 5, y is equal to minus 1. That's how we solve it. The procedure is very important. This one, these kind of calculation, you know it very well. That's not a big deal. This one, and how do I define it properly to make the process faster? I'll check with the LCM, 2 and 3 LCM, or even no problem, you multiply with 3 here, you multiply with 2 here, not a big deal. What if some other numbers are there, like 4 here, 6 here? You multiply with 6 here, and you multiply with the 4 in the second equation. Not a big deal at all. You need to find a common term. You need to create a common term. You do the same. You do a process whatever you want, but multiplication is very important. Okay, and then you'll find it. You'll find the value of y here because you cancelled x there, right? You will find y, then further you'll apply the value, then find your x. That's it. So these are all basics, fundamentals. That's how we solve the questions. But from the third question, we are going to express the situation in terms of mathematical modeling and hence solve it. Okay. So third question, hope you have copied this. Third question, we'll check with the question. A number is equal to 4 times itself less 75. What is the number? They said everything. Okay. The statement is given. We need to model it. Okay. What could be the model? Very simple. A number. Let's say the number is x. In mathematics, we have one powerful variable. Whenever we don't know anything, we don't know one number or one variable, we'll put the variable x, right? So let's take the number to be x. Third question, the number is x. What was the data given, question given? A number is equal to 4 times itself. 4 times itself less 75. Less 75. That's it. A number is equal to 4 times itself less 75. That's it. You understand. Then you bring the x here, 75 there. 75 equals to 4x minus x. You will get 3x is equal to 75. Hence x is equal to 25. That's it. But this mathematical modeling is very, very important. Okay, this is very important. How do I solve it? A number equals to 4 times itself less 75. See, this is also fine. I can reframe the statement. A number is 75 less than 4 times of itself. A number is 75 less than 4 times of itself or 4 times of it. In that case, what could be the number? The same modeling. same model. The statement is little bit differed. Okay, same question only. Here they've given you straight away a number equals to 4 times itself less 75. Similarly, let's check with the next question. Check with the next question. You tell me the model. You know how to find the, I know you will find the answer, but still, tell me the model. Once you find the model, finding the answer is quite simple, very simple. First, model it. Fourth question, twice a number, same, the number is x. Twice a number equals 5 times the same number plus 18. You model it, tell me the model. No, 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 I didn't ask you the answer. I asked you to find the model. Tell me this kind of equation. I know you'll find the answer. That's not a big deal. Ah, yeah, very good, very good. What's the name? Sharmista. Nice name. Okay, twice a number is 5 times the same number plus 18. Question 4, the number is twice the number is 5 times the same number plus 18. Then you bring it there, it becomes 3x equals to 18. Then x is equal to 18 divided by minus 3, hence x is equal to minus 6. That's how we get x is equal to minus 6. Very good, very good. Yeah, Deepan, right answer. Still, you will bring this 5x there, not a big deal. All right. Fifth question. And this is where you have to think a little more, okay, to get the process done faster. Okay. Fifth question. Look at the question. The sum of 3 consecutive even numbers is 78. What is the smallest number? So whenever you check with the question, check with the data, check with the question first. What is the smallest number here? Right now. So when what is the question asked? The question asked, no, the variable or the number. That particular one, the particular thing should be the first variable. Should be the variable which I want to find. Likewise, we have to frame that. Okay. So first question, fifth question, sum of 3 consecutive even numbers. Consecutive even numbers means the difference will be 2, right? Because 2, then 4, then 6. That's the consecutive even number. Set of consecutive even numbers. 2, 4, 6, 8, 10, it goes on. Okay. For every other number, for the every next number, 2 will be increased. So for that case, I want to find the smallest number. Let's take the smallest number to be x, least number. Among the 3 numbers, first number is least. Next number, 2 more, because consecutive even numbers, it is given in the question itself. So plus x plus 2, and then 2 more added up with this. So that we'll get next part. That is x plus 4 equals to, what was the sum? 78. Yeah, 78. Then find the number. That was the question. No, we need to find x. See, always remember that this is my first number, second number, third number. Among these 3, smallest, second smallest, largest. Suppose if they ask you to find the largest number among them, you put this value as x. Okay, for a change. This is my smallest case. And we'll solve it. That's not a big deal. What if they ask you the largest case? I want to find the largest number. In that case, you bring this variable. Okay, here I've used x now already. So let me use y. The same sum, 78, no problem. Adding 3 consecutive even numbers, the sum is 78. Find the largest number. The same question, except the smallest, I'm replacing that with largest. Quite simple. Y is there. Here, 2 lesser. You're going back. Here, 4 lesser. Because among the 3 numbers, if I put in ascending order, this will be the largest one. And 2 lesser here, 2 lesser here. You'll go reverse. Right? That's how you have to think. And why should I think like that? Very simple. In this case, also you'll find the answer for this case. Largest number. But still, there you have to find the first, you have to find the smallest number first. And then add 4. 2 process you are doing. Here it's simple. You can easily find it. But certain cases, you have to do a lot of process. To avoid that process, to avoid wasting time, I can think like this. so that I'll get the answer faster, right? So I don't want this equation for now. We'll solve this equation. So this fellow becomes 3x plus 6, 2 plus 4, 6 equals to 78. Then 3x is equal to 6 goes there, 72. Hence x is equal to 72 by 3, it is 24. That's it. Yeah, Suresh Ram, x is equal to 26. That means the middle term is 26. You need to find the least term. Among the three terms, you might have taken x minus 2 is the least term, right? Then x minus 2 will be 24. That's why. That's what I'm telling. See, you would have taken like this. Some of you would have taken like this. Middle term x, x minus 2, then x plus 2. You would have got x is equal to 26. So this is my middle term. This is my least term. This is my largest term. What is the least term? What is the smallest term? This one. X minus 2. 26 minus 2, 24. That's how we get it. Okay. I don't want to worry about this. So think like it. Think like this process. You will easily find the answer. Okay. All right. Sixth question. We are done four, no? Five, five. Yeah, sixth question. The numerator of a fraction is 5 less than the denominator. If 2 is added to both the numerator and denominator, it becomes 4 by 5. Find the fraction. See, for this case, there is a silly trick. First, check with options. Definitely, most of the cases, 1 or 2 will be the answer options. Straight away, you can find the answer. But here, if you look at the options, everything is difference 5. Right? Denominator is 5 more than the numerator. 11 by 16, 13 by 18, 18 by 23, 23 by 18. Everywhere. Okay, but in look at this, option D is not falling under the circumstances given in the question. Look at this, 5 denominator is 5, sorry, numerator is 5 less than the denominator. That means numerator should be lesser. Option D is not right. So among the three options, which is right? That's how we'll think, right? But in examination, in proper examination, this is just an example. In an examination, they'll give you 4 clues. Among 4 clues, 2 clues will almost near to the answer. Among those two, only one will be the right answer. But other one, no, you can easily neglect it by looking at the question itself. Okay, well, that's how we can find the answer in examination. Suppose if you don't have enough time, and if you couldn't find the answer faster, you want to find the answer faster, stick with the options. That's a very rare case scenario. But in this case, we shall solve it. 5 less than the denominator, no? Okay. So question 6. The number would be like this. Denominator is x, numerator is 5 less than the denominator. That's how it is given, right? And now something is added to the number, right? Numerator and denominator. 2 is added to both. Okay, 2 is added to both numerator and denominator. Hence, the value becomes 4 by 5. Find the number then, right? So this one, x minus 3 divided by x minus 2. Let me do one thing. I'll bring the 5 here. 5 times of x minus 3. So this one equals to 4 times of, I'll bring it here, x plus 2. We'll solve it further. 5x minus 15 equals 4x plus 8. So bring this 4x there, 15 here. Okay, 5x minus 4x will be x here. 15 will come here, 15 plus 8 will be 23. I found x is equal to 23. So from this I can tell x is 23. What is x minus 5? That will be 18. That's your answer. 18 by 23. Okay, once you model it properly, you can easily find the answer. Okay, so that is my number, denominator, numerator. Whereas numerator is 5 less than the denominator. And then if I add 2 on both numerator and denominator, the value becomes 4 by 5. Becomes equal to. Solving them, you get the answer. The same question. Okay. Here they've given you 4 by 5. No. What if the value becomes 3 by 4? See, 4 by 5, you found the answer. It is 18 by 23. Okay, same question. The numerator is 5 lesser than the denominator. If I add 2 on both numerator and denominator, the value becomes 3 by 4. Then what is that number? Tell me the answer. Narmada, for what do we have the question? 13 by 18 for this question, is it? What if it is 3 by 4? Is that so? Narmada, Hemant Kumar and Dibakar. Ah, yes. Right answer. Answer would be 13 by 18. Yeah, right answer, right answer. Fine. So you'll solve the same process, you'll get the answer. Not a big deal. Okay. And I hope you would have come across this kind of question in your number systems. Previous class, number systems. We shall solve it anyway. The sum of the digits of the 2-digit number is 7. When the digits are reversed, the number is increased by 27. Find the number. Okay. So in this case, always remember okay, whenever you deal with double digit number, okay, the number will be of the form AB or XY, let's say. So 25, 2, 5, 92, 9, 2, 9, 2, 92, right? 90 means 9 times of 10 and 2. That's how we can solve, right? 29, 2 times of 10 and 9. That's how we have it. But in this case, how do I define properly? Okay, let's have it as a formula or the fixed value, actual value or actual number and reverse number. You have it. Let's say actual number is always 10x plus 5 because x is in the 10th place, right? And if you reverse it, it will become 10y plus x. Okay, so let's say this is R, this is A. So actual number, reverse number. You think like this. You have it for now. Now what was the question given? One number is sum of the digits is 7, right? So x plus y equals to 7. That's my equation number 1. Then when I reverse, it is 27 more than the actual number. When the digits are reversed, the number is increased by 27. So if I reverse it, it is 27 more than the actual number. That was the question. When I reverse, it is 27 more than the actual number. Then what is a number? That was the question. This fellow, what is R? We know 10y plus x equals to 10x plus y plus 27. And you can bring it there. So you will have 10y that goes there minus y, 9y. X minus 10x, that becomes 9x minus 9x equals to 27. Since all these numbers are multiples of 9, I can divide by 9 throughout. I'll get y minus x equal to 3. Okay, so I can do it like this, minus x plus y equal to 3. That's my equation number 2. I've got x plus y equals to 7, minus x plus y equals to 3. What will I do? I'll do very simple. I'll do 1 plus 2. First equation plus second equation. What will happen? Very simple. This plus x minus x, they'll get cancelled. Plus 5 plus 5, it will be 2y. Okay, 7 plus 3, 10. Then y is equal to 5. If y is equal to 5, what is x? You apply 5 here, then it becomes 2. Therefore, x is equal to 2. Hence, the number would be xy 2, 5. That's how we get it. It's confusing. Good question. No. I'll tell you, Rupashri. You always remember this. Okay, actual number, it has to be in the form 10x plus y. How? So let's take 49. I can tell it like this: 4 times of 10 plus 9. How did I get this? We need to understand one simple idea. This is unit digit, this is 10th digit. Okay, unit digit, unit place, and 10th place. So unit place will have only one, that's 9. 9 times of 1. So unit place. Tens place will have those numbers of tens. Okay, 49. The word itself says 40. 40 means 410. And then 19. That's how altogether it becomes 49, right? So this is the format, and this format is generalized here. Actual value is 10x plus y. Reverse value, when you reverse it, what happens here? 94 will come, no? That is 9 times of 10 plus 4 times of 1. This means x and y has got interchanged. Okay, ba? So x and y has got interchanged, and this is my reverse value. And what was this is the generalized condition. Forever, whenever you get a question like this, for n number of times, any number of times, you use the same pattern, you'll get the same answer. Not a big deal at all. So what was the question? Sum of the digits. 4 plus 9. If I add it, it becomes 13. No. Likewise, if I add the digits of the number, it becomes 7. Xy is a number, right? So x plus y will be 7. And then when I reverse the number, it is 27 more than the actual number. When I reverse the number, it is 27 more than the actual number. Reverse equal to a plus 27. Can I tell? And then using the values there, instead of r, I'm using 10y plus x. Instead of a, I'm using 10x plus y. Solving further, I've got the equation like this: 9y, because 10x goes there, minus x minus 10, it will be 1 minus 9x, right? So here, if it goes there, 10y minus y, it's just simple 9y. 9y minus 9x is equal to 27. Since all the numbers are multiples of 3, sorry, multiples of 9, dividing by 9 throughout, I'm getting y minus x is equal to 3. So I'll just reverse the number, minus x plus y. I want x at the first. Okay, minus x plus y equals to 3. Then adding those equations, I'm getting the value of y. From there, I'm getting the value of x. Hence, I've got the answer. You get it, ma, Rupashri? Super, super. Now, tell me the answer for an 8th question. Most of you would have found out. How 25? X is 2, y is 5. Apply it here. That is my actual number, no? 10 times of 2, it will be 20. 20 plus 5, 25. Right? We know the values. X is equal to 2. That is 2. I'm sorry. 2, 5. The number is 25. All right. Good. Yes, Siddharth. Right answer. What was the question? 8. Sum of the digits of the 2-digit number is 12. Right there. Then, so question 8, you get like this: x plus y equals to 12. Then one more thing is given. The difference between the digits is 6. Okay. So it can be x minus y equals to 6. Right? That's one possibility. Or another possibility is there: x plus y equals to 12. Not a big deal. Y minus x is equal to 6. That is also possible, right? 25, 52. The difference between the numbers is 3 itself. Between the digits, 2 minus 5. No, 2 difference 5. It will be 3. 5 difference 2. It will be 3. But 25 and 52 are different numbers. 2 different numbers. Likewise, I've got 2 different scenarios. So if I solve this, what is the answer? If I solve this, what is the answer? We'll solve this first because yellow color, no. So that's my first equation. Second equation, I'm going to solve them. First equation plus second equation, I'll get x gets cancelled. 2y is equal to 18. Then y is equal to 9. I'm using that somewhere else in the, let me use in the first equation. This implies x is equal to 3, yeah, because x plus 9 will be 12. Then 9 goes there, subtracted, x is equal to 3. Hence the number will be 39. This is one scenario. And if I use this case, That's my first equation. Second equation, if I add it, 1 plus 2 will give me 2x is equal to 18, then x is equal to 9. Using somewhere else, let me use it in the first equation. Then y is equal to 3. Then, therefore, the number is 93. 93 here, 39 here. Both mean the same as per the question. Sum of the digits, 12. Difference between the digits, 6. Yes. But what is the answer? Check with the options. Both of them are there. 39 is also there, 93 is also there. Option C, fortunately, we have got either A or B. Hence the answer. Okay. All right. The answer is either A or B. The price of 10 chairs is equal to the 4 tables. Okay, this is how the application would be. The price of 10 chairs is equal to the cost of 4 tables. We'll solve them. Let me have chairs, the cost of chairs to be C. The cost of tables to be T. We'll have it as such. The price of 15 chairs and 2 tables together is 4,000. Then total price of 20 chairs and 4 tables is, we need to find the answer, right? We shall solve it. For this case, clue is given. I told you no. One clue, one equation would be given. So second statement is equation. First statement is clue. What was that? 10 chairs is equal to that of 4 tables. Question. Price of 10 chairs is equal to that of 4 tables. We have it as such. Not a big deal. And then comes price of 15 chairs. Okay. So price of 15 chairs and 2 tables together is 4,000. Okay. So this one I can convert it. Both numbers are multiples of 2, right? So I can have it like this. 5c equals to 2t by dividing by 2 throughout. Taking 2 common and then cancel it out. Both mean the same. 5c equals to 2t. I'm going to use this 2t as 5c. This is my clue. I'm going to use this clue here in the equation. So first clue, second equation. Okay. So 15c plus, so instead of 2t, I'm going to use 5c. 5c equals to 4,000. Then comes 20c. 20c equals to 4,000. Then c equals to 200. Okay, 0, 0 gets cancelled. 400 by 2, it will be 200. We got the cost of chair. I want to find the cost of table. I'll use it here. Okay, so using in the first equation, I'll get it like that because it's clue. Straight away you can find the answer. If you use it here, you'll have to solve it further. Okay, so we shall use it here. 5c equals to 2tm. So 5 into 200 equals to 2t. So 2 gets cancelled. 200 gets cancelled. You'll get 100. Then t equals to 500. The cost of table is 500. Now they asked you to find the cost of 20 chairs and 4 tables. So 20 chairs and 4 tables. I'm going to use it. I'm going to solve that. 20 chairs. Cost of chair is 200. We got it. And the cost of tables is 500. Okay. 20 into 200 will be 4,000. Plus 4 into 500 will be 2,000. Hence, the resulting value will be 6,000. Hence, the answer is 6,000. Very good. Very good. 1, 2, 3, 4, 5, 6. Wow. 7 people found out the answer. Excellent. This is how you get the answer. You understand? Quite tricky, but silly. One clue, one equation. Simple. Okay. 10th one, homework. 11th one, I'll solve. 10th one is homework. You can solve it at your home. Not a big deal at all. 11th one. There are certain number of hens and goats in a farm. If there are 25 heads and 68 legs while counting, find the number of goats. Good question. Video is lagging. Screen frozen. Can you see me, guys? How about now? Now you can. Very good. All right. So let's go to the question 11. There are certain number of hens and goats. Okay. So question 11, hens and goats. Okay. If you count heads, it is 25. So 25 heads are there. So number of hens, number of goats together 25 heads, because no hen will have two heads, no goats will have two heads. So 25. If you count 111, it will be 25. Now what is happening? If you count legs, it is 64. Is it 68? If you count legs, it is 68. Okay, see in this case, idea is quite simple. Goats will have 4 legs. Hens will have 2 legs. I'm going to use that. 2 legs for hens and 4 legs for goats. So this is my first equation. Here, it is a multiple of 2, all the numbers. So let me divide the equation by 2. I'll get it like this then. H plus 2 goats equals to 34. That is my equation number 2. They ask you to find the number of goats. I want to cancel H. Simple. So first equation, second equation minus first equation. Because you've got 2g here, 1g here. So you'll get positive value, right? So H will get cancelled. 2g minus g will be 1g, 1 goat, I mean 1g value. And 34 minus 25, it will be 9. Number of goats is 9. Simple. That's it. Okay. Siddharth and Anju, yes, right answer. That's how we get it. Okay. Hens and goats together, it is 25. If you count heads, that is number of hens and goats together, it is 25. If you count the legs, so hens will have 2 legs and goats will have 4 legs. Together, it is 68. Solving them further, I've got the number of goats to be 9. Okay. So out of 25, 9 are goats. The remaining would be hens. Hens would be 16, right? Therefore, hens would be 16. Correct? Remaining would be 6 hens. So I don't want this first of all. Still, you can find the answer. Not a big deal. In that case, tell me the answer for 12th one. You solve it now. Tell me the answer. Good. Very good. There are certain number of peacocks and tigers in a zoo. Okay. So question 12. Peacocks and tigers in a zoo. That is, if I count the heads, it is 50, right? Yeah. If there are 50 heads and 130 legs while counting, 130 legs. Peacocks will have 2 legs and tiger will have 4 legs. 130 legs. Okay, so this is my first equation. Here everything is a multiple of 2, hence I'm dividing by 2. I'll get P plus 40, yeah. Right, 2T equals to 65. Equation number 2. Okay, what was the question? Find the number of peacocks. Oh, see, if you solve this, if you subtract this, you will get tigers, right? You want to find the peacocks. So this is my second equation. The first equation, multiply by 2. I'll get it like this, 2p plus 2t equals to 100. Second equation, have it as such, p plus 2t equals to 65. Subtract these two, you will get the answer. 2t minus 2t gets cancelled. 2p minus p will be 1p. 100 minus 65 will be 35. Hence the number of peacocks is 35. Straight away you can get it. Okay. Or otherwise you can straight subtract these two equations, you will get t. Right? Tiger will be 15. Remaining will be peacocks. If you subtract these two, 65 minus 50 will be 15. That is tiger. Tiger will be 15. Out of 50, 15 is tiger. Remaining will be 35. 35 are peacocks. You can think like that also. Not a big deal. Anyway, you'll find the answer. Okay. So whichever is faster for you, you do it. That's up to you. Okay. And now comes 8 problems. For that, we need to understand certain ideas. I'll tell you. Copy them until this. Okay. See, age problems, they belong to simple equation itself. But here you need to understand certain ideas. See, here we in the previous two problems we had no hens will have 2 legs and goats will have 4 legs. Peacocks will have 2 legs and tigers will have 4 legs. Likewise, there are certain inheritance in the question. We need to inculcate the ideas by ourselves. That's in reality itself. Likewise, okay, there are certain facts. I'll tell you, and certain ideas also. The clues also given. Let me give you the clue. Let's say like this: A is 2 years elder than B. A is 2 years elder than B, elder than B or elder to B. In this case, I'm going to write the equation like this: A equals to B plus 2. A is 2 years elder than B. Similarly, A is 2 years younger than B. Younger than B. In that case, A equals to B minus 2. That's very simple. These two are very simple, not a big deal. But sometimes they might give you times like this: A is 2 times as much as B. A is 2 times as old as B. Okay, let me write it like this: A is 2 times as old as B. In this case, I'm gonna have A equals to 2 times of B. And these three are very simple, you'll understand. But very rare case scenario, like maybe like 1%, you might get rarest form scenario, you might get this kind of question. A is 2 times more old as B. It's not like older as B. It's just more old, 2 times more old as B, or 2 times more as old as B, or 2 times more than B. Let's say like this: 2 times more than B, 2 times more as old as B. See, if you think like superlative degree, comparative degree, and all statements, if you think like that, the statement will go wrong. Don't think like that. This is just a scenario given in the question. Okay. So A is 2 times more than B, or 2 times as old as B. So as old as B, 2 times more as old as B. In this case, how do I define this equation? A is 2 times B as old as B, 2 times B more than B. It has to be done like this: 2 times B plus B. If it is 4 times more than B, 4 times of B plus B. This is a very rare case scenario, but these three are very simple. You can get it, but still, this one you need to understand. Sometimes they might give you a silly trick in the question. Okay, if you solve that scenario in this kind of equation, you'll get an answer that will be there in the option. Sometimes that will not be there in the option. Then what will you do? You'll think on the question again and again. You'll waste the time. That's why I wanted to get this one. So 2 times more than B, 2 times more as old as B. In that scenario, B's age plus 2 times of B's age, like this. Okay. And then one more fact is there. Whenever the number of year increases or decreases, the same number will be increased from all of the ages. So let's say I'm here, you're there. Okay. So after 2 years, I will be 2 years elder. You will be 2 years elder also. Right? 2 years more. Your age will be 2 years more. Your age will not be the same. It's not constant. It will keep increasing. So let's say 5 years ago, my age was some number. 5 years lesser than my age at present. Similarly, 5 lesser than your age at present 5 years ago. Okay. So something like this you need to understand. 2 years later, 2 years hence. Hence means future tense. Okay. 2 years later, 2 years hence, that will be plus future. And few years ago, 2 years ago, 3 years ago, 3 years back, whatever it is, it belongs to past tense. Okay, you need to understand that. That's it. So these are the facts you need to understand. If you have doubt, you can ask me. Otherwise, we shall go to the question. I'll wait for 5 seconds. No, 10 seconds. All right. Let me solve the question. Let's solve the question. Raju's age after 15 years will be 5 times his age 5 years back. Fantastic question. What is the present age of Raju? So in this case, we have to deal with past, present, future. Question 13, right? So Raju's present age is, so present, past and future. So present age it is R, let's say. Past age, future age. Past age, what was the reference there? 5 years, no, Raju said after 15 years. That is in future, R plus 15. 5 times as old as he was 5 years back. Huh? So 5 years back, R minus 5. They are comparing this one and this one. So in the future age is 5 times the past age. Okay. Raju's age 15 years after would be 5 times, okay, 5 times his age 5 years back. That's it. Solve it, we'll get the answer. R plus 15 equals to 5R minus 25. Okay. Then what will happen? So bring this R there, 25 there. It becomes 40 and this is 4R. Hence R is equal to 10. So Raju's present age is 10. It is 10. This will be 5. This will be 25. Yeah, you get it. You get the right answer. We'll compare it. So present age is 5. No. Present age is 10. Past tense it was 5 and future tense it will be 25. See, 15 years later will be 5 times 5 years back. Yeah, right answer. Okay. Done with 13th, 14th. Elder one, younger one. Huh? Okay. Question 14. Let's take 2 persons. A is elder than B. Okay, A more than B means A is elder than B. 2 persons are there. Age of 2 persons differ by 16 years. So in that case, A minus B equals to 16. That's my equation number 1. Okay. Second case, 6 years ago, the elder one was 3 times as old as the other. Okay. So 6 years ago, A minus 6, B minus 6. So these two are there. Okay. 6 years ago, what was the give? We'll do one thing. I'll leave a space now. Leave this. So 6 years ago, elder one was 3 times as old as the other. Okay. Elder one, younger one. So elder one was 3 times as old as the other. Other means younger one. Okay. In that case, what is the age of younger one? I want to find the present age of younger one. So A and B, they are, A is the present age of elder one, B is the present age of younger one. So in that case, I want to find B only, no? So very simple. I'm going to use this as a clue. How? Very simple. B equals to, I'll bring this there, or even not B, A in terms of B. A in terms of B, B plus 16. That's my equation number 1. Let's say I'm going to use B plus 16 here. Okay, use 1. What will happen? B plus 16 minus 16 equals to 3B minus 18. So this is my equation. Solving them will get me the answer. So 16 minus, oh no, that is not 16 minus, it is 6. Okay, so B plus 10 will be there. 3B minus 18 would be there. So 18 goes there, B comes here. So 18 goes there means 28. It is 2B, yeah? 3B. 2B will be there. This implies B will be equals to 14. Okay. Age of the younger one is 14. You got it. Anju, right, ma? Solving them, we get the answer. Thing is very simple. I'm using this as a clue. I can also have this an equation, this and as another equation, solve them. That's also possible. But here It is given like this. No, it's a lengthy process to solve everything, to convert into a single equation. That's fine. You can also find, but this one, if I use this clue here, I can straight away find the answer. Okay. So 14th, the answer is 14 itself. Yeah. 15th. Fantastic question. 15th is quite simple. Similar process. Age of father is thrice that of a son. 3 years ago, the sum of their ages is 46. Find the age of son. Age of father is thrice that of son. That is, they are dealing with the present, the first equation. So F is equal to 3 times of S. Can I have 15th question? F is equal to 3 times of S. So let's say equation 1, we will have it as such. And then 3 years ago, sum of their ages is 46. So father minus 3 plus son minus 3. That is their 3 years ago ages. And they added together, it is 46. We'll get it like this. I want to find the age of son. Find the age of son. So I can use this in here. Okay. So use 1. So 3s minus 3, yeah. 3s minus 3 plus s minus 3 equals to 46. So 4s minus 6 is equal to 46. 4s is equal to 52. Then s is equal to 13. 52 by 4, it is 13. Simple. Hardly 20 seconds. Provided you decode the scenario in terms of equation. You model the scenario in terms of mathematical equation. That's it. You'll easily find the answer. Okay. Once again, please. Yeah, sure. What was the question? Father's age is thrice that of son's age. Father's age is thrice that of son's age. That's cool. Next one. 3 years ago, sum of their ages is 46. 3 years ago, father's age would have been f minus 3. Son's age would have been s minus 3. F minus 3, s minus 3. Added together, it becomes 46. 46. That was the question, right? And then I'm going to use 3s. Why? Because they asked you the question to find the age of son. Solving them, s is equal to 13. Super. 3 years ago, father was twice as old as his daughter. See, 16th question, let me give you the clue. You solve it at your home. Question 16, solve it when you have free time. 3 years ago, father was twice as old as his daughter. 3 years ago, father minus 3 years, daughter minus 3 years. 3 years ago, father was twice as old as his daughter. So their past tense here will be f minus 3, d minus 3, because their percentage, we are considering the percentage of father is f, percentage of daughter is d. 3 years ago, f minus 3, d minus 3. F minus 3 is twice that of daughter's age, d minus 3. 2 times of d minus 3. We have the first equation. If the father is 21 years elder to daughter, what is his age? Father is 21 years elder to daughter. So you will have it like this. F is equal to d plus 21. Now I want to find the age of father. So from this I can have d is equal to f minus 21. I'm going to use it here. I'll get the answer. Simple. Okay. That's my 16th question clue. We can solve it. You've got 45. We'll check on it. Yeah, right. So if you solve it, father's age would be 45. So once you solve it, okay, fine. So if you solve them, you get the answer 45. Okay, let's go to 17th question. The total ages of A, B, and C at present is 90 years. So A plus B plus C, 90 years. 10 years ago, the ratio of their ages was 1:3. That means we'll first fix the values 10 years ago. Okay, or we shall find it easily. Let me solve them in 17th question. Percentage of ABC. ABC percentage, not a big deal. If I add them, it is 90, right? Sum of the ages of ABC is 90. 10 years ago, the ratio of their ages was 1 to 3. That is A minus 10, B minus 10, C minus 10. They are in the ratio, they said 1x, 2x, and 3x, right? So that's their ratio, right? So at present, sum of their ages is 90. 10 years ago, sum of their ages would have been 60, yeah, because A will lose 10 years, B will lose 10 years, C will lose 10 years. If I add all these three things, I'll get 60, yeah, right? So this fellow, 10 years back, 10 years back, sum of their ages, this is the ratio of ages, right? So x plus 2x plus 3x, sum of their ages is 60. How did I get this? Because each one of them would have lost 10 years. So A will be reduced by 10, B will be reduced by 10, C will be reduced by 10. On the whole, the sum of the values would have been reduced by 30. So 90 minus 30, it would become 60. And before 10 years, the ratio of the ages was given like 1x, 2x, 3x. That is x plus 2x plus 3x. Right? So if you understand better, you can straight away come to this equation. If you practice more in the 8 problems, you could straight away come to this equation and you'll easily find the answer. This means 6x is equal to 60, then x is equal to 10. Right? So this is fine. What was the question? What is the percentage of B? Okay. Then 10 years ago, what was the age of B? It was, so this is the age of B and ABC. Right? B was 20. Right? B's age, B equals to 2 times of x. That is 20 past. So percentage of B, very simple, 20, 10 years. Why? Because the past value was 10 years ago. Then at 10 years ago, it was 20 years old. B was 20 years old. At present, he will be 30 years old. Okay, all these things I'm given you in terms of equation. You can think easily, you'll find the answer. How do I think? Very simple. I'll tell you like this. So you can copy this, no? You will copy this a little later. Let me tell you how to solve it in mind. A plus B plus C is 90 at present. 10 years ago, A plus B plus C would have been 60. Correct? Then 1x plus 2x plus 3x, that was given in the question. Because they are in the ratio 1x, 2x, 3x. If I add it up, it becomes 60. Because it was given in the first clue that at present, sum of their ages is 90. 10 years back, it will definitely become 60. Because each one of them will lose 10 years. So 60. Right? So 1x plus 2x plus 3x is equal to 60. Then what is x? That is 10. Right? So 1x plus 2x plus 3x. So 2x, that is what I want. B, I want to find the age of B, right? So B is equal to 20. 10 years ago, B's age is 20. At present, he'll be 30 years old. Copy them. 18th homework, simple. 19th, 18th homework, 19th, solve and tell. One year ago, Deepa was 4 times as old as Priya. Very good, very good, very good. Yes, Siddharth, right answer. Fortunately, you can check with the option also for this question alone. But you have to solve in terms of equation, actually speaking. So 1 year ago, we shall solve the 19th question. 1 year ago, Deepa was 4 times as old as Priya. So D minus 1 equals to 4 times of P minus 1. Okay. Then Deepa's age will exceed Priya's age by 9 years. 6 years hence. 6 years hence, Deepa's age will exceed 9 years. See, in this case, leave 6 years hence. Why? Let me tell you one scenario. See, maybe like probably most of you would have been like 22 years now. I'm 29 years. So I can tell I am 7 years older than you. Approximately, I can tell, right? I'm 7 years older than you, right? So in that case, after 10 years, I'm still 7 years older than you because you will also increase by age gradually. I'll also increase by age gradually by one year, right? So every year, how many ever years you passed? Okay, you pass. The difference between their ages will be the same. Here they are talking about this Deepa and Priya, right? Deepa after 6 years will exceed Priya's age by 9. They are telling like this. Whatever the number of years they exceed, they're traveling, okay? 6 years, 10 years, whatever it is, no problem with that. So leave that 6 years hence, leave it, forget about it. Deepa's age is 6 years, 9 years more than Priya's age. So Priya plus 9. Then what was the question? I need to find the ratio between the Deepa and Priya, right? I'm going to use it somewhere. I'm going to use this here. Okay. First equation, second equation, use 2 in 1. Okay. So P plus 9 minus 1 is equal to 4P minus 4. Right? So P minus 8 equals to 4P minus 4. Is it so? Yes. Bring it here. Goes there. Goes there. So 12 is equal to 3P. Then Priyanka's age would be 4. If P is 4, what is D? Using in the second equation. D equals to 9 plus 4. D equals to 13. They asked you to find the ratio between the age of Deepa and Priya. That is 13 is to 4. That's it. Okay. Last question. Solve it. Tell me the answer. Similar process. Sachin was twice as old as Ajay 10 years back. How old is Ajay today if Sachin will be 40 years old 10 years hence? Good question, no? Once you're done, solve the question. 20th. Last question. Yeah, Siddharth, right answer. Yeah, Anju, right? Correct answer. Okay. So answer is 20. I'll tell you how to solve it. 20th. 10 years ago, Sachin, Ajay. 10 years ago, Sachin was twice as old as Ajay. That was given in the question. And then, how old is Ajay today? So at present, I want to find Ajay. So this is Sachin's percentage. This is Ajay's percentage. We'll have it. How old is Ajay if Sachin will be 40 years from 10 years now? Okay, from 10 years now. That means 10 years in future, Sachin's age would be 40. At present, Sachin's age would be 30. Can I tell? 10 years later, Sachin age is 40. At present, his age would be 30. No other go. Right? I'm going to use it here. This is the clue there. That's the equation. This is clue. I'm going to use it there. So equation 1, equation 2. Right? So using 2 in 1. Use it there. You will get the answer. 30 minus 10 is equal to, have it as such, a minus 10. 20 equals to 2 times of a minus 10. Then 220 gets cancelled, it is 10. So bring the 10 there. You'll get like this. 10 is equal to a minus 10. A equals to 10 plus 10. That's how a is equal to 20. Okay? Very silly. All right. We'll do one thing. Time is 10:35 only now. I'll give you all the ideas about this probability because we are going to deal with probability today, right? So simple equations and then probability, isn't it? Wait. Yeah, simple equation and then probability. That's the schedule for the day. So we are going to deal with, we'll deal with the probability for now. Okay. And we shall solve the question paper. Is that okay? After the, shall we solve the question paper after break? Or we'll take a break now and then at 11 o'clock we shall have the content completely. Which one is better for you? Break now or break at 11? Option A, break now. Option A, break now. Option B, at 11. Which option do you prefer? Majority B. AB மாறி மாறி வருது. 1 2 3 4 5 6 7 8 9 10. Most of you are telling option B. So we shall do that. See, 11th, probability is quite simple. I'll tell you an easy way. Okay. So we'll stick with this. Okay. Probability is quite silly. Before going to probability, let's do some refreshing work. Either A or B. That's up to you. So we shall solve it now. Okay. Quite silly. So apart from this probability, before doing the probability, let me give you a silly idea. Idea means let me give you a silly question. Okay, mathematical question, or I hope you are done with this blood relation, no? But I'll give you that question, something like refreshing. Okay, fine, no need of pen. I'll tell you the question. I'll tell you the question only once. You need to listen to the question properly and answer the question. Okay. So if you know the answer in Tamil, because if you are in Tamilian, you can tell the answer in Tamil. Otherwise, you can tell that also in your own language. I'll try to decode it. Okay. Fine. Blood relation question. I have mom. Okay. My mom has one elder sister. Okay. That elder sister's husband has one elder brother. My mom has one elder sister. That elder sister has, that elder sister's husband has one elder brother. Okay, hope you understood this scenario. No worries, I'll tell you the question again. Not a big deal. That elder brother, I said no, that elder brother has 3 sons. Out of 3 sons, second son has one daughter. Who am I to that daughter? I'll tell you again. My mom has one elder sister. That elder sister's husband has one elder brother. That elder brother has 3 children, 3 sons. Among the 3 sons, second son has one daughter. Who am I to that daughter? Let's say the daughter is Aarti. Okay, that's my real family scenario. That's elder, that daughter, no, that daughter's name is Aarti. Who am I to Aarti? Who's Bharat to Aarti? Uncle, aunta. I am male. Who am I to that Aarti? See, in that, if it is in English, I want a particular idea. Particular statement, exact value, no exact word. You cannot tell randomly, okay, uncle, auntie, no. Cousin row, no, it's not cousin. Cousin, mama, no. Uncle, uncle, I cannot accept it. It is somehow related to that word only, but I'm not going to accept that. Aarti is cousin daughter or niece to you. Cousin daughter. Okay, okay. Somehow related. Yes, that. Okay, good. Maternal uncle, no. Daughter, ah. That's my brother's daughter, no. Yes, exactly. Kanagashruti, right answer. Only one so far found out. Very good, very good. Oru word da. So that's my Anna. Let's say that Aarti's brother is my Anna, my brother, elder brother. Excellent, Suresh. Superb decoding. But still, that's my Anna. That's my brother, elder brother. In that case, who am I to Aarti? Good. I'll be Chitapa. Chitapa means, ஐயோ இங்கிலீஷ் என்ன சொல்லுவோம். Chitapa means it's somehow related to Appa, no, paternal uncle. So from with respect to Aarti, I am her paternal uncle, right? So I am her dad's cousin, younger brother. Okay, somehow it is younger brother, cousin. Okay, one விட்ட cousin, ரெண்டு விட்ட cousin, whatever it is. Somehow I am younger brother. So younger brother means obviously I am Chitapa. In Tamil it is Chitapa. In Hindi it is Chacha, I believe. Telugu it is, I don't know. I forgot it. Whatever it is, it is Chitapa. In English, generally speaking, it is paternal uncle. Okay. All right. Now let's go to probability. We have certain other questions. I'll ask you the question at last after the break. Okay. Some other puzzle like blood relation question. Now we'll deal with the probability. Okay. Just 17 minutes are there. Hardly within 10 minutes we'll finish off. Probability, you will have to deal with basic idea. So in CSAT, they'll give you basic idea. Okay. I believe you would have come across this principle of counting and permutation combination. If it is and, you multiply. If it is or, you add it. Something like that, right? So let me tell you that again. In probability, first you'll have to deal with principle of counting. Okay. Always remember, if it is and, if you're dealing with the word and, or in between the processes, not boy and girl, not father and mother, it's not like that. So if you're dealing with the process, if there are two different processes and you have to do both the process A and process B, in that case you need to multiply. If you are dealing with or, process A or process B, okay, let's say solution A or solution B, product A or product B, in that scenario you will have to add it. Okay, you think like this, we can easily find the answer. And one more thing is there, one more basic idea is there. Worst case scenario, always you have to think in terms of worst case scenario for probability. Probability is not about the easiest possibility. Okay, it's all about the worst case scenario and other way possible things also. Okay, so worst case scenario, scenario. Okay, in this worst case scenario, you have to think with the numbers, in terms of numbers. If it is worst case scenario, if you think in terms of numbers, okay, you start from the bigger number. Okay, you have to solve in terms of descending order. You start to solve in terms of descending order. You think like this, you'll easily find the answer. Descending order. That's very, very simple. Okay, this is a very important word, descending order. Okay, always probability is all about dealing with the worst case scenario. And whenever you think and get the question in terms of numbers, worst case scenario and numbers, you start with the you do in terms of descending order, you'll easily get the answer. No more confusion with that. I'll tell you one such idea. Let's say, no, we'll solve the question a little later. I'll give you an idea simply. Uh, Let me give you a simple puzzle. Something like this. You have a pretty big box, a big box, let's say. In the big box, in that big box, you have got 11 pairs of socks. All the 11 pairs of socks, each pair is different in color, different in design, even different in brand. No two pairs are similar, not even similar. They are all different, unique. Everything is unique. Okay, 11 pairs are there. 11 each pair is different. What I'm going to do, the pair of socks is there now. So I'm going to mix everything. So now I'm having 22 single socks. Pair means two same design, same model. Okay. So I'm mixing everything up, messing it up. So everything in the box, you will have 22 different kind of socks. Okay. Now you have to think like this. You're going to do a simple process. The process is quite simple. Blindfoldedly, you're going to take one socks. In one take, you're going to take only one socks. Okay, one take, one socks. How many takes can you take? How many times can you take so that you will get a pair? You will get a pair. Tell me the answer. You think like this, worst case scenario. You tell me the answer then. How many times would you take to get a pair of socks? No, not 10 times. It will be more than one time. 22, no, Siddharth. It is total number of times. No. Murli, no. Maximum 21 times. Good, but not right answer. 11, no, no, no. It is not 11 times. It is 12 times. Because totally 11 pairs are there, no? So 11 different varieties of socks. Okay. So altogether it is 22. Okay. So let's take first take. Let's do one thing. Let me take first take. What will happen? One socks. Second take. Worst case, I have to think in terms of worst case scenario. Second take, different socks. Third take, different socks. 11 times. I would have taken one socks from each design, each pattern. So 11 takes over. On the 12th take, I will take one socks, no? That one socks will be a pair of any one of the 11 takes I've already taken. Correct? So totally 12 times I have to take so that I will get a pair. You understand? Could you please explain again? Yeah, Suresh. Very simple. In a box, there are 11 pairs of different kind of socks. Each pair is unique. No two pairs is same or similar. Not even that. Okay. So each pair is unique. I'm mixing all the 22 socks, or each sock, no, 22 socks, and then messing it up. And then I'm taking one socks from one take blindfoldedly. Okay. What is the minimum number of takes? Minimum number of takes I could take so that I will get a pair. That's the question. So what is happening? For the first 11 times, 11 takes, I will take no. Worst in the case of worst case scenario, I have to think like this only. No other go. So if I take one time, I'll get one pair, one socks, one design of socks. Second time, worst case scenario, some other design. Third time, some other design. Fourth time, some other design. 11 times, unluckiest case scenario, worst case scenario, I will take 11 different socks. 12th time, I will take one socks. No, that one socks will be a pair of any one among the 11 socks. Then on the 12th time, I will get a pair. That's it. You understand, Suresh? And all the others, you got it? If you have doubt, you can ask me. 10 times is for one time I take one sock, keep it with me, get the same sock, it will take. No. What was the question? What is the minimum? Like this. Very good, very good. So your comprehensive idea is quite simple, but still you think with the question like based on the question, basic idea itself. No need to think complicated way. Okay. So here What is the minimum number of times? That's how you have to think. All right. Super. Right? Fine. Suppose, what if I have 24 pairs of socks? Same scenario, same question. 24 pairs. Each is unique. How many times would I take to get a pair? 24 pairs of socks. 25. 24 pairs, no, 24 different pairs. So totally 48 pairs of socks would be there. 48 would be there. Out of which I'm going to take 24 chances. Each one would give me one different designs. 25th time I'll take one pair. What if the question is like this? 24 pairs of socks are there. Each pair is unique. I'm mixing all the socks, single socks, and then I mess it up. I take one socks in one time, and one socks at a time. How many times? What is the minimum number of times I can take so that I will get two pairs of socks? Mm-hmm. Two pairs of socks. Two pairs. See, for one pair itself, you are taking 25 times. For two pairs, you have to take. Each one is unique. Each socks is unique. No, it is not 50, buddy. It is 26 times. Most of you couldn't understand. See, very simple. I'll go with a simple number. In a box, there are 10 pairs of socks. Okay. So 2 times of 10. 2 times of 10 socks. Right? 2 times of 10 numbers, let's say. 2 times of 10 number of socks. You have it. 20 socks are there. I want to get one pair. What will happen? 11 times I have to take. To get one pair, 10 times I will take 10 times, all the 10 times I will take different socks, and I'll get one pair. On the 11th time, I'll get one pair, because that one, no, the 11th one will be the pair of anyone among those 10 unique socks. Correct? That's the worst case scenario. What if I want to get two pairs? The same process. First 10 times, I didn't get any pair at all. Okay. Then on the 11th time, I got one pair. On the 12th time, I've got another pair. Correct? Altogether, I've got 12 times. You understand? Always you have to think in terms of worst case scenario. That is how probability works. You understand? All right. So everybody understood, I believe. Done. So probability is always between probability value. Probabilistic value is always between 0 and 1, or probability value is always between 0% and 100%. You can have any fraction between 0 and 1. It is always a proper fraction. Here, it is always a proper fraction, and whose value is always less than 1. Proper fraction values is always less than 1, no? That's all. In between, in terms of fraction, it is always a proper fraction. In terms of percentage, it is always less than 100%. Okay. And one thing we need to understand, probability of impossible event and probability of sure event. One event is not at all happening and the probability is 0. One event is always happening. It will happen forever. It is 1. Probability of impossible event is 0. Probability of sure event is 1. You remember these things and we'll decode the values, the word. How do I get probability? How did I solve it? Everything. Okay. So first copy them. All right. Now, probability value. That's a basic. basics of the basic. Probability is a ratio between favorable event, favorable event and total number of events. Total number of events. Now, favorable, that's the favorite one. Okay, event. Here, event, total number of event, fine. New word comes, event. What is event first of all? So let's go with the coin itself. Okay, when I toss a coin, I'm tossing a coin. No, that's what we call experiment. I'm doing something, that's experiment, and I get something. I'll get either head or tail, and we call it as result, and that result is called as event. Okay, when I do experiment, I will get results. Okay, that result is called as event, right? In this event, how likely would it happen? What is the possibility that this kind of event would happen? And thinking like that, no, so when we think like that, we will get to the process, we call it as probability, and this probability will give you the expansion of ideas of statistics. Okay, probability and statistics together will get you to the uh, other idea, other world. We can call it as artificial intelligence. Okay, leave them, I don't want them. All I want is this idea only. Experiment, when I do the experiment, I'll get a result. That result is otherwise called as event, and based on that event, that those event, plenty of events would have happened. Okay, so very simple, two coins, oh, one coin, only one coin. If I toss a coin, I'll get either head or tail. I want to get head. My favorable event is only one time, but totally how many events can happen? Two events. Head or tail can happen, but how many heads can it happen? Only one head will be there, 1 by 2. That's how the probability goes. 1 by 2 will be the process, and we have certain other formulas, number of events divided by in probability of A. We'll use this idea, right? Probability of A equals to n of A by n of S. N of S means sample space, collection of all the possibilities, all the events. We call it as sample space. S stands for sample space. Collection of all the events are called as sample space. Totally how many events happened? Number of sample space. Total number of events. Okay, how many events are yet to are to happen as per my wish? That is my favorable event, N of A. So favorable event. That's how we get it. Okay, favorable event divided number of total number of favorable events. Let's say number of favorable events divided by total number of events. This is how the probability works. And we have certain other formulas also. We shall learn the formula at 11:25 a.m. Okay, so I'll give you break. We shall have the break now from 11 o'clock. I'll give you break until 1 minute. I'll check with the questions. Probability. They are silly. We shall straight away go to the all right. So let's have the class back at 11:20. Okay, so I'll be back at 11:20. The class will be started sharp at 11:21 maximum. Okay, you can go for break. Thank you.
Recording stopped.
we shall start. Okay, so I told you this one, right? Probability basic ideas. See, we have certain formulas to find the answer, but provided we have to understand some topics, okay, ideas, statements. So first thing is um, independent, dependent, independent variable, dependent variable. Similarly here, independent event, dependent event, and exclusive, exhaustive. First we'll deal with exclusive. Exclusive is the basic one. Exclusive. Exclusive event. That means whenever I do one operation or I get one result, the other result will be excluded. Let's take one coin. Simple example. So if I take a coin, I'll toss it out, I'll get head. That means tail is not coming. Tail is excluded. Okay. If I get tail, head is excluded. Correct? So that way, likewise, we'll get the answer. Okay. Exclusive event. So one event excludes the other. So it can be um, taking a coin, we get only two results. If head comes, tail will not come. If tail comes, head will not come. What if I take a die, one dice? I just toss a die. I just throw a die. I'll get 6 results. 1, 2, 3, 4, 5, 6. Among the 6 results, let's say I've got 3. So 1, 2, 4, 5, 6. Other 5 results are not coming. I'm focusing only on 3. So only 3 comes, other results didn't come. In that case, we call it as exclusive event. Get it? Exclusive event. Okay. So in this case, exclusive event. And then independent event. Independent event, obviously not at all related. Not related. I'll tell you one thing. Independent event. Let's say I have 2 coins. I'm tossing one coin. I'm getting head. I'm tossing other coin. I'm getting head or tail. I can get head or tail. Head or tail. See, getting head on the first tail, will it affect the process of getting head or tail in the second coin? I've got 2 coins. So coin 1, coin 2, coin 1, coin 2. If I get head in the first tail, should I tell I'm getting, can I tell I'm getting head in second tail? I will get head in second tail. Like second coin? No, it's not possible. You cannot exactly tell. You may get head, you may get tail. It is possibility. It is a possibility. You cannot exactly tell which one you can get. So getting a process, getting an event here will never affect the result of this case. It will never affect the event of this case. So we call it as exclusive event. Okay, right. We call them as exclusive events. Okay. Sorry, not exclusive, I'm sorry. Independent event. So one is not related to other one. Okay. So this one, getting head or tail, will never affect the result of getting head or tail in this coin. We call them as independent event. And independent, inside this independent, each coin will have exclusive event. Okay. Independent, exclusive. And we need to understand one other word, intersection, right? So in both the cases, we have one thing, P of A intersection B. 2 events are there, A and B. So first coin, second coin, we had no. So first event, second event. Here, in the case of exclusive event, probability of A intersection B. Let me write in some other color. Probability of A intersection B will never happen. It's an impossible event because exclusive event. So head is coming, tail is also coming. That is not at all possible. If I toss a coin, head will come, tail will also come. That's not a possibility. Only head will come or only tail will come, right? So in this case, exclusive event. In the case of exclusive event, P of A intersection B. Intersection means and this has to happen, and this also head has to happen, and tail also has to happen. That is not possible. Impossible event, 0, right? Here, independent event. So in this case, we have the formula like this: probability of A multiplied by probability of B. Probability of A multiplied by probability of B, provided the events are independent event. Okay. All right. Yes. So these two are the other cases, independent event. In the case of dependent event, okay, so we cannot call exactly dependent event. We should not call that, but we can have some other criteria or some other idea of events. I'll tell you. So first copy them. Okay. So this one, probability of A given B, that is one event has already happened. B, there is an event B, it already happened. With respect to B, what is the probability of getting an event A? What is the probability of getting the event A? So we are finding the probability of getting event A, whereas probability of B has already happened. Okay, it's a part of dependent event. Okay, so in this case, we have the formula probability of A intersection B divided by probability of, oh, that's B, probability of B. What if we get like this? Probability of B given A. I want to find the probability of an event B, whereas A already happened. So in that case, similar process. Probability of A intersection B divided by probability of A. Very simple. Whatever comes to the denominator will come to this denominator. Simple. Yes, Siddharth. Right. Okay. So this event, this set of events are called as conditional events or conditional probability. So A has to happen, whereas B has already happened. First case. B has to happen, whereas A has already happened. That's the second case. Okay. No doubt. Fine. Okay. So done. So we are done with this. Next, we have to learn some formula. I'll tell you the formula. Repetition without repetition things are there. That's it. Just 3 or 4 formulas get to learn, and we shall straight away go to the questions. Copy them. Okay. Then comes formula number 1. Probability of A or B. A or B. Union means it can happen or that also can happen. Okay, A or B. So in that case, we have probability of A plus probability of B minus probability of A and B or intersection B. That's one case. And probability of A by A. So let me have X equals to 1 minus probability of X bar. Probability of X bar is equal to 1 minus probability of X. That means one event has happened. Okay, so let's say 100%. Out of 100%, 20% is apple. So I've got a number of fruits, certain number of fruits. Different, only 2 varieties of fruits are there. Fruits. Okay, one is apple, other one is mango. Let's say. So out of 100%, 20% are apples. So remaining would be mangoes, right? What is remaining? 80%. How do I get it? 100% minus 20%. So these percentages are given. No, I can convert that as a fraction in by means of this percentage concept. So 100% total. From that I can subtract 20%. This is nothing but 1. This is nothing but 1 by 5. So remaining would be 4 by 5. So this is my possible probability of apple. This is my probability of mangoes. Right? So probability of apple, out of 100 fruits, 20 are apples. This is nothing but 1 by 5. Out of 100, remaining are mangoes, 80, 4 by 5. So this is mango, this is apple. Probability of apple, probability of mango. That's how we can think. No need to copy them. Copy these two formula alone. Yeah, something like this. What is the probability of getting? Probability of not getting this guy. Okay, probability of not getting 3 in a dice. Okay, I'm tossing a die. I'll get 6 results. Out of 6, I should not get 6. Sorry, I should not get 3. Let's say, what is the probability of not getting 3 while tossing one die? One dice. What will happen? You'll get 5 results. 5 by 6. That is your probability. I'll tell you how to define that. You just remember these two ideas. That's enough. Okay. All right. Probability of A and B, probability of X bar, fine. And then A bar, I've given you these two formula, no? So these two are enough. That's it. In the case of probability, these are the formulas. That's enough. And you need to understand one thing: repetition without repetition. See, whenever you have a repetition concept, do classical method. Okay. Okay. Without repetition. Whenever you deal with without repetition, do combination method. This is enough. Okay, just these ideas. This is enough. You can find the answer. And I'll give you an example. And based on the example, you can try to solve the question. Okay, copy them. And certain other facts are there. I'll tell you the facts also. I believe you're done with the calendar concepts. Are you? Are you done with this calendar concepts? All right. So we'll have to deal with that. Let me ask you a silly question. I told you, no, puzzle kind of question. What is the probability of your birthday? Tell me the answer. Your birthday. What is the probability of your birthday? 1 by 365 normal year, 1 by 365, 1. That's a sure event. Very good. Nice idea. 366 in a leap year. Superb. Kanagashruti 1 by 7. Nice. You've got plenty. 365.25. Wow, that's amazing. All right. The answer is 1 by 7. If it is a non-leap year, it is 1 by 7. If it is leap year, it is 2 by 7. How? I'll tell you one thing. See, I asked you about what is the probability of getting your birthday, right? So day. Out of 7 days, you can get 1 day, right? So this is based on odd days. Always remember odd days concept. You know this odd days concept, right? Based on the calendar concepts. Idea is quite simple. We'll deal with non-leap year. So in this case, so generally speaking, leave the birthday content. Generally speaking, we have one factual question. You might have got this kind of question. What is the probability of getting 53 Sundays in a non-leap year? What is the probability of getting 53 Mondays in a non-leap year? Any day it can be, not a big deal. What is the probability? For that, we need to decode this. In a non-leap year, you will have 365 days, no? Sorry, 365 days. That 365 days can be converted like this: 364 plus 1. That is, every non-leap year will have one odd day. These 364 will be converted in terms of 52 weeks and one day here, right? This is what we call odd day. And this one day can be any day. So this one day can be, sample space can be Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, and Saturday. So these days, Among 7 days, it can be any one day. What is the probability? So probability of 53rd day, 53rd particular day, 53rd any one day, not a big deal. It is always out of 7 one day. 53rd Monday, it will be 1 by 7. 53rd Tuesday, 1 by 7. 53rd Wednesday, 1 by 7. Right? For the case of probability of getting your birthday is 1 by 7 always. Be it a leap year, be it a non-leap year, not a big deal. It is always 1 by 7 because out of 7 days, it can be any one day, leave it. But here, we are dealing with the 53rd particular day. It's like I have to deal with one particular idea. So let's say this is non-leap year, right? So this in the non-leap year, for the first 52 weeks, you will get one particular day. Let's take Saturday, right? Today Saturday. What is the probability of getting 53 Saturdays in a non-leap year? That's the question. In that case, idea is quite simple. First 52 weeks, right? So these 364 days will give you 52 weeks. In the 52 weeks, you will have one Saturday in each week. So 52 weeks done, 52 Saturdays done. On the one day, right, the odd day, that one day can be any one day among these 3 days, these 7 days. So in these 7 days, what is the probability of getting Saturday? 1 by 7. This is my non-leap year content. What if it is for leap year? That's 2 by 7. I'll tell you how. Okay, copy them faster. Okay, let's go to non-leap year. Sorry, leap year. It has got 366 days. That is 364 plus 2. Correct? So here we have got 52 weeks. Not a big deal. Anyway, you will get one particular day on every 52 weeks. So 52 particular days. Let's say Saturday itself. 52 Saturdays will be done. But in these 2 days, it can be a pair. What is the possibility? Say, let's say the sample space would be like this. Sunday, Monday. It is one possibility. So this is two. It contains 2 odd days, right? It can be a pair. Sunday, Monday, or Monday, Tuesday, or Tuesday, Wednesday, or Wednesday, Thursday, or Thursday, Friday, or Friday, Saturday, or at last Saturday and Sunday. Look at this. So it can be a pair. 1, 2, 3, 4, 5, 6, 7. So totally 7 pairs are there. Among the 7 pairs, I want to get a Saturday. What could be the pair? It can be either Saturday, Sunday, 1 pair, or Friday, Saturday, 2 pairs. So it can be any one of those 2 ideas, 2 events, right? So what is my probability? Probability of getting 53rd Saturday for a leap year. It is out of 7, 2 events, 2 by 7. It is always factual. Straight away look at the question, think whether it's a leap year or non-leap year. If it is a leap year, it is 2 by 7. If it is a non-leap year, it is 1 by 7. Always fix it up. Okay, simple. You have to check whether it's a leap year or non-leap year. That's what I want. Simple. Okay. All right. And some other facts are there. Whenever you toss a die, now first we'll deal with coins. Whenever you toss a coin, you'll get 2 results, head or tail. Whenever you toss 2 coins, you'll get 4 results. 3 coins, 8 results. 4 coins, 16 results. So it will be going in terms of multiples of 2, powers of 2. I'll tell you. So sample space in coins. Copy them faster. Hope you're done. Sample space. Sample space for coins. It is always 2 to the power n. If it is 1 coin, 2 results. 2 coins, 2, I mean 2 to the power 2, 3 coins 2 to the power 3, 4 coins 2 to the power 4. It goes on like that. Okay, and the sample space for the dice, it is on the power of 6 to the power m. If it is 1 die, 6, 2 dice, 36, 3 dice, 2 and 6, it goes on. Okay, well, right. And then a new idea, and it is always, you would have come across this topic. All of you would have come across this topic, cards. There are two defined, totally 52 cards are there. Red color cards, black color cards, 26 red color cards, 26 black color cards. Okay, among which in this 226 we have got diamond, and then heart. Here 2 cards, spade, clubs, or claver, clubs, let's say clubs. Okay, wow. So diamond will have 13 cards, hearts will have 13 cards, spade, and then clubs 13. So everywhere 13 cards. Here face cards, non-face cards. Face cards means the card which we have with picture. Okay, king, queen, jack, face cards. Joker is not at all included in the picture, so you should not include Joker in this case. Okay, only 52 cards are there, right? So among the 52, face cards will be 4. So let me write them here in different color. Face cards are king, queen, jack. Okay, ace card only one, that is A. And number cards 2, 3, 4, 5, 6, 7, 8, 9. Okay, totally 13 cards would be there. Simple, right? So very simple. The probability will be asked like this. Out of 52 cards, what is the probability of selecting a face card? Face card means 3 cards in one face, in one section, right? One design. In diamond, you will have 3 face cards. In heart, 3 face cards. Here 3, here 3. Altogether, 12 face cards will be there. Out of 52, you're going to select 12 cards. It can be any one among the 12. So the probability will be 12 by 52. Number of favorable events is 12 divided by total number of events 52. 12 by 52. That's my answer. That's how the answer will be. You understand? 10 number cards. 10 also will be there. Oh, 10 is there, no? Right. Is it 10? No. 9? Yes, correct. I'm sorry. So 10 until 9 cards. 9 cards would be there. 9 cards. So I just wrote until 9. I'm sorry. It is 10 also would be there. 8, 2, 3, 4, 5, 6, 7, 8, 9, 10. KQJ. 10, 13 cards would be there. So here, this is face cards. What if they ask you about non-face cards? Very simple. Leave these 3. Remaining would be non-face cards. Totally 10 numbers are there, no? So totally 10 numbers in one section. Altogether 40 numbers. So 40 by 52. Something like that. You understand? So probability of face cards, probability of non-face cards. Probability of face cards, let me write it here. Probability of face cards will be 12 by 52. Probability of non-face cards will be 40 by 52 remaining, right? That's it. This is how we think. Or even I can tell 1 minus 12 by 52. Who's that? Yes, Siddharth, right. 1 minus 12 by 52. Non-face card means F bar. I can think like that also. Because we had one formula, no? Probability of X bar is equal to probability of X. 1 minus probability of X. Likewise, we can think in this case. Okay, wow. So coins, dice, and cards. Apart from that, balls in a bag. It can be like that. We can think and we can solve. See, everything in all the questions, in all the data given in the probability, you can think in a classical way, basic way, and find the answer. Provided you have to imagine properly. I'll tell you how to find the answer. We shall go. We shall go to the question paper, and I'll tell you if there is any other shortcuts to be mentioned. I'll tell you. Page number 177. Yeah, 177. Question number 1. Page 177, question 1. We shall solve it. We are done with these ideas. We shall solve it. Once we are done, I'll ask you certain other questions also. These questions will be very silly. We can easily solve it. So first question, tickets are numbered from 1 to 20. So totally how many numbers are there? Page 177, question 1. Tickets are numbered from 1 to 20. So number of sample space would be 20. Correct? Then what is the question? Then a ticket is drawn at random. What is the probability that the ticket is drawn as a number which is a multiple of 3 or 5? It has to be a multiple of 3 or it has to be a multiple of 5 or both. Okay. So very simple. They ask you to find probability of multiple of 3 or multiple of 5. They ask you like this. Whenever you get such word 3 or 5, A or even B, in that case you think like this. You have to think like this. This is not B, it is 3. Multiple of 3 or multiple of 5. So multiple of 3 or multiple of 5. So let's take multiple of 3 first. How many multiple of 3 are there? Number of multiple of 3. How many are there? Within 20, multiples of 3. 3, 6, 9, 12, 15, 18. 6 numbers are there. How much? How much are there? So multiples of 3, let me write. Okay, I'll do one thing. I'll write it here. Multiples of 3. It will be 3, 6, 9, 12, 15, 18. So they are number of multiples of 3. It is 6. Similarly, multiples of 5. Multiples of 5, they are 5, 10, 15, 20. Okay. So number of multiples of 5, it is 4. So I want to find multiples of 3 and multiples of 5. Only 15 is there, right? Multiples of 3 and a multiple of 5. Only 15 is there. Correct? Yes or no? So multiple of 3, multiple of 5. Only one number is there. Number of multiple of 3 and multiple of 5 will be 1. So what is my formula? I want to find the probability of A union B. What is the formula? Probability of A. What is the probability of A? This one. This probability. Probability of 3x will be 6 by totally 20. 6 by 20. Probability of B. Probability of 5x would be 4 by 20. Probability of A intersection B. Probability of 3x and 5x would be 1 by 20. We are going to use this formula. Probability of A plus probability of B minus probability of A intersection B. 9 by 20. Hence the answer is 9 by 20. Good question. But they are asking or, right? Yes, they are asking either 3 or 5. Are they dependent or independent? They are dependent. Or they are not independent. Selecting one number will affect the selection of other number also, right? If you select 3, it will affect the other numbers also. Correct? Totally 6 numbers are there. If you select 3, next time if you select, it will be 5 times only, not 6 times. Correct? So they are dependent. What if you select 15? It can be a possible of 3 or it can be a possible of 5 also, right? Multiples of 3 or multiple of 5 also. That's why they are all dependent. They are not exclusive even. See, if I select all the multiples of 3, we have one number which is common. They're not exclusive. Correct? They're not exclusive. In that case, what would I do? I have to deal with this idea only. So whenever you have this kind of question, so probability of A or probability of B, union means A or B, union means or, intersection means and, you have it in your mind always. Okay, always. Whenever you get such question, first think like this only. This is a basic idea. Okay, instead of 20, if they give you a large number, then is there any shortcut to solve? Good question. Is there any shortcut to solve the questions? No. There is no shortcut to find the answer for this. If you practice more, you can straight away come to this answer. Shortcut in the case of shortcut, how do I tell? I'll tell you. In the case of straight away process, I'll tell. First copy them. I'll tell you how to find the answer straight away. Straight away to this line. I'll tell you. Copy it. Okay. So let me go to the shortcut process. Not shortcut, like understanding and the finding the and finding the answer faster. Something like that. Okay. Applying the concept straight away to the answer, like this. Totally, how many numbers are there? I want to find the probability. Totally, how many numbers are there? Totally 20. Okay. How many multiples of 3 are there? 3, 6, 9, 12, 15, 18. 6 numbers are there. How many multiples of 5 are there? 5, 10, 15, 20. 4. But here we have one term common. Here also 15, here also 15 is there. I've got two 15s. I have to take one 15 out. That's your answer straight away. Totally 20 numbers are there, out of which I want to select a number which is a multiple of 3 or multiple of 5. Let's take 1, 2, 3, 4. So this one you must remember, you must think in your mind, imagination process. Okay, what are the multiples of 3? 1, 2, 3, 4, 5, 6. 6 numbers, done. Remaining. So I want to select a multiple of 3 or multiple of 5. So do we have multiples of 5 here? Yes, of course. 1, 2, 3, 4. This means I have cut down 15 two times. So I can take 15 for only one time. So I've taken for 2 times. I have to reduce 1 time. How do I reduce 1 time? Minus 1. Minus 1. So this process is in terms of formula. That's what the formula we had. P of A union B equals to probability of A plus probability of B minus probability of A intersection. Probability of A plus probability of B minus probability of A intersection B. So this one you can think and straight away find the answer. If there are plenty of numbers, no problem. Think in terms of the numbers. You have to imagine the numbers and then solve it straight away. You understand? Any doubt, any confusion on this? In that case, tell me the answer for next question. A bag contains 20 balls, 8 are green, 7 are white, 5 are red. What is the probability? What is the minimum number of balls that must be picked up from the bag blindfolded without replacing any of it to be assured of picking at least one ball of each color? Very good, Siddharth. I've given you one idea, right? Worst case scenario, descending order. Very good. Descending order. 8 plus 7 plus 1. Correct? 8 plus 7. 15 times you have taken one ball. Whereas you've exhausted 8 green balls and 7 white balls. On the 16th time, if you take one ball, that means you have taken one white ball. That means you have taken at least one ball from each color. You understand? You're going in terms of descending order. Okay. So question 2, descending order. First 8 balls and then 7 balls and then it can be 5 balls, but they ask you to find the minimum number of ways. So leave that one. You can convert it in one ball. That's it. You understand? 8 plus 7 plus 1. Because blindfoldedly, first I'm taking one worst case scenario. I'm taking first ball. It can be the green ball, second ball, green ball, third ball, green ball, fourth green ball, fifth green, 8 until 8 green balls. Done. Ninth ball, it can be white. Worst case scenario. Okay. 10th ball, white. 11th ball, white. Until 15 balls, white. Okay. First 8 balls, green. Next 7 balls. Until 15 balls, it is white. So green balls, white balls, done. On the 16th take, I'm taking one ball. That is a white ball. And at that moment, it means I have taken one ball from each color. Red taken, green taken, white taken, red also taken. So 8 plus 7 plus 1, 16. You understand? 16 times I have taken. The same question, can I ask you in terms of probability? Yes. What is the probability of selecting one ball from each color? What is the probability of selecting one ball from each color with the minimum number of takes? It would be 16 by 20. Simple. But you'll not get such questions. In such question, you will get some other quantifying ideas. You'll deal with that. When we have questions, we'll solve it. Third, little confusing. Good question. Okay, deepen, little confusing. I'll tell you. See, don't deal with the probability. Just deal with the counting, principle of counting. Totally, you've got 20 balls. Worst case scenario, blindfolded, unluckiest day. Let's imagine that you're taking first ball. Worst case scenario means whichever is not at all possible, whichever will not give you the answer faster will happen. Whichever will give you the possibility faster will not happen. That is the worst case scenario, no? So faster possibility will not happen means it has to be a slower possibility. Slower possibility means it has to take more number of times. More number of times means you have to deal with the highest possible number, descending order. First highest number here is 8 green balls. First 8 ball, you're taking 8 balls. All the 8 balls are green balls. Worst case scenario I'm talking about. Okay, first 8 balls, green balls, leave it. Next 7 balls, white balls, again leave it. And on the next ball, that is on the 16th ball, it is white ball. No, not white ball, it is red ball. So on the 16th ball, if it is red ball, at that moment I realize that, or the guy who's next to me, who's not blindfolded, who's looking at me taking the balls, he realized that I have taken one ball from all the colors. Okay, at the 16th take, at that moment. Correct? So that's what I want. What is the minimum possibility of number of takes? Then 8 times we will take one white ball extra. Okay, why can't it be 5 red balls, 7? Good question, Suresh. I told you no. 13 is also there. I want you to solve in terms of worst case scenario, right? Whenever they ask you in probability or in mathematical principle of counting, wherever it is, always you have to think in terms of worst case scenario. There is no luck at all. Just worst case scenario. You understand? It's always like that. Yes, Charan. Exactly. Yes. Suppose if you're replacing that, you will never get it. Correct? See, worst case scenario, here it is, you're not replacing the balls. You take one white ball, keep it aside. You take one other white ball, keep it aside. But if you're replacing it, you replace the ball, you just took the ball and you ask your friend to mark the ball, replace it. Again, if you take it, there is plenty of chances that you take the same ball. N number of times, infinite number of times, you will take the same ball only. Correct? That's the worst case scenario. Think like that. Always worst case scenario. Always. Okay, you understand? Okay, so in that case, let's go to third question. 2 dice are tossed. So 2 dice are tossed. What is the number of possibility? Total number of possibility. 6 to the power 2. Correct? So question 3. So sample space. Number of sample space when the dice are thrown. 2 dice are thrown. 6 to the power 2. Totally 36 events are there. Fine. Now, the probability that the total score is prime number. Oh, prime numbers are 2, 3, 5, 7, and then 11. So these 5 are prime numbers, which will give you the total, right? You have to find the total of the numbers. No, you have 2 dice. In one day you'll get 1, other day you'll get 1 or 2 or 3, something like this. I'll get you the possibility here itself. Let me write them. so that you'll understand for now. Right, until the 6, 6 you will have these result 36 result, correct? So it will be 2 2. So these are the possibilities. 1 1 1 2 1 3, everything is there, right? Now what is the question? You have to add the numbers. So in the first day it is 1, in the second day it is 1, first day 1, second day 2, first day 1, second day 3. Here first day 1, second day 4. Here first day 3, second day 2. That means first day shows 3, second day shows 2. You add it up, it becomes 5. That's a prime number. Likewise, you check with the sum as a prime number, how many possibilities are there? So what are the possibilities? Sum as a prime number, sum as 2 prime number, only one possibility is there, you'll write it here, 1 1. Sum as 3, what are the possibilities? 1 2 will come, 2 1 will come. Anything else? No, not possible. Oh, I'm sorry. Then 4 will not be the prime number. 5 is a prime number. 1 4 is possible, 2 3 is possible, 3 2 is possible, and 4 1 is possible. Anything else? Not possible. Then 7 is a possibility. 1 6, 2 5, 3 4, 4 3, 5 2, and 6 1. Correct? So if I add everything, I'll get 7 as a sum. Okay, and then 9 is not a prime number. 11 is a prime number. 6 5 and 5 6. Only these two are the possible values. Correct? Anything else? Nothing. 13. If you want to get a 13, it has to be 6 7 or 5 8 4 9. Nothing is there in the set. Right? So only these values are there. Highest sum is 12. Least sum is 2. So between 2 and 12, what are the prime numbers? 2, 3, 5, 7, and 11. Beyond that, no, it is not possible. You've got the values, right? How many numbers are there? Totally 36 probability I want to find. Totally 36 numbers are there. What is the possibility? Number of possible 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15 by 36. If I solve it in terms of 3 table, I'll get 5 by 12. That is my answer. 5 by 12 is my answer. You understand? See, why did I write this? You have to remember this. It has to be in your mind always. So whenever you think, whenever you have this kind of question, you straight away go to this idea and you'll find the answer. You write the values, how many terms are there? Totally 15 terms are there out of total events, 36 events. Number of favorable events divided by total number of events, 15 by 36. You get the answer. Okay, copy them. So tell me the answer for fourth question. It is similar to the second question. Okay, so it's somewhat like basic equations, simple equations. Tell me the answer for fourth question. Okay, right answer. There are some balls of red, green, and yellow color lying on the table. There are as many as red balls as there are yellow balls. So red balls is equal to number of yellow balls. Red is equal to y, r is equal to y. There are twice as many as yellow balls as there are green balls. So this statement is tricky. There are twice many yellow balls as there are green balls. How many ever green balls are there? Double the value will be the number of yellow balls. Correct? I've given you the clue. Tell me the answer there. Only one guy. Siddharth, right answer. Others, you try to find the answer. Before that, copy them. you done with this copying? Yes, right, Kanakashruti. Charan Surya, no. Check with the number properly. Not number, check with the equation properly. All right, so let me go to the equation. Yes, who's that? Deepan, right answer. So question 4, what was the first clue, first statement? There are as many as red balls as there are yellow balls. Red balls equals to yellow balls. And there are twice many yellow balls as there are green balls. So how much ever green balls are there, 2 times of that will be yellow balls. From this I can tell red is equal to yellow is equal to 2 times of green, right? That's what we have right now. And there are okay, then the number of red balls. Number of red balls is double the green balls. Number of red balls is double the green balls, or number of red balls is equal to yellow balls, whatever it is. We'll check with the options. Is equal to the sum of yellow and green balls? No, not possible. Double the number of green balls? Yeah, that possible. Is equal to yellow balls minus green balls? Yellow balls? No, y minus 2g is not possible and cannot be assured. No. We can find the answer, no? Option B is the right answer. Number of red balls is equal to twice the number of green balls. Very good, very good, very good. Now, fifth question. Yes. Yeah, Charan. See, you just observe the question properly. So there are as many as, twice many as. Those words, no? You have to think like that properly. All right. So fifth question. That's a tricky question. Fifth one is very tricky. I'll tell you how to solve it. It's a new method to solve the question. You can use formula and all. If you had you got this question in your 11th or 12th standard, that question is for 5 marks in your state board. If it is CBSE, it is almost 4 marks, I believe. 4 marks, 6 marks, no, 4 marks question. Such a question is this. Okay. But you can solve it within 2 or 3 lines. I'll tell you how to solve it. See, a man and his wife appear on an interview. Question 5. Man, wife appear for the interview for a vacancy on the same spot. Correct? The probability of a husband selection is 1 by 5. Probability that husband is selected is 1 by 5. Probability that wife is selected is 1 by 7. 1 by 7. Okay. What is the probability that only one of them is selected? See, only one of them selected is very simple. Idea is quite simple. If husband gets selected, wife is not selected. Husband selected and wife is not selected. That's one case. Or wife selected and husband is not selected. That's another case. 2 cases are there. Can you understand that? The statement says only one of them got selected. That means husband selected means wife will not be selected. They are dependent. They are interrelated. Or wife selected, husband will not be selected. Those 2 are related to each other. So this one or that one, case 1 or case 2, you need to add it anyway. I'll tell you how to solve them. First, we'll define this reverse category. That is, husband is not getting selected as 4 by 5. How? Out of 5 events, only 1 event husband will get selected. Then out of 5 events, husband will not get selected means remaining part. Out of 5 chances, only one chance husband will get selected. Remaining will be not get selected. Right? Similarly, probability of wife not getting selected. Out of 7 events, only 1 event she will get selected. And on other events, she will not get selected. That is 6 by 7. Or even you can use the formula 1 minus 4, 1 by 5. 1 minus 1 by 7. You will get the same answer. Okay. What is I want to find the probability of only one got selected. Right? So in that case, husband is getting selected and wife is not selected. This is one scenario. Or a wife is selected and husband is not selected. You get it? You understand this scenario? This statement, this idea, whatever you thought. Okay, this is a possibility, right? Husband may get selected and wife is not selected. That's one possibility. Or Wife may get selected, husband will not get selected. That's another possibility. This one or that one. Okay, if this happens, this also has to happen. Correct? This is not an exclusive event. This is an independent event. This one and this one. Okay, both of them are getting selected. That is also a possibility. But in the question, it should not come into the picture. Correct? Only one of them gets selected. Right? So we'll deal with this. Probability of husband getting selected is 1 by 5. Probability of wife not getting selected is 6 by 7 plus 1 by 7, 4 by 5. Correct? So what will happen? 6 by 35 plus 4 by 35. You will get 10 by 35. In terms of 5 table, you will get 2 by 7. That's your possibility. Simple as such. You understand? You need to understand this one alone. Once you get this, you can easily find the answer. For this case, you need to use formula and all in your 11th or 12th standard. I don't want them. You're not getting 4 marks or 3 marks. You're getting only 2 marks if you select the right option. Otherwise, you lose 2 and 0.66 also. Right? So think wisely and find the answer. Got it? Sixth question, you know how to find the answer. Tell me the answer. What is the probability of getting 53 Mondays in the year 2020? 2020 is a leap year. I want to get 53 Mondays. As per the fact, it is 2 by 7 always. Sixth question, 2 by 7. Fifth question, 2 by 7. Sixth question, 2 by 7. Both the answers, 2 by 7. 5 and 6. Let's jump to 7th question. Okay. Copy them. We shall go to 7th question. Once we are done. Okay. Again, this question is quite silly and tricky. We shall solve it. Let's go to the 7th question now. A box contains 50 bolts, 150 nuts. Half of the bolts and half of the nuts are rusted. If one of them is chosen at random, what is the probability that it is rusted or a bolt? So here we need to understand one thing. Okay, rusted or bolt. Question number 7. Let's say event A is rusted. Event B is bolt. Event B is bolt. In that case, how do I solve it? They ask you to find probability of A union B. What is the formula then? Probability of A plus probability of B minus probability of A intersection B. That's what I want, right? This is the formula I want to use. Now they've given you 50 bolts and 150 nuts. So bolts and nuts. Bolts and nuts. 50, 150. What was the clue given? Half of them are rusted. Half of the nuts and half of the bolts. Okay, half of them. So this is rusted. Rusted means it is half of them. That is 25. Here half of 75. Okay. So totally how many of them are rusted? Probability of A. Now why probability of A? We'll deal with number of A. Number of rusted. Number of rusted evlo? How much? Number of rusted together. Totally 75 plus 25. 100 are rusted. Number of bolts. Number of bolts. Totally 75 are bolts. Number of rusted bolt. How many of them? Number of rusted bolt. Out of 75 bolts, rusted bolt is 25. Right? So 25. What is the formula then? We need to use a formula. Probability is equal to 100 plus 75 minus 25 whole divided by. Totally how many are there? 50 plus 150. Totally 200 are there. Right? Okay. Totally 200 are there. 50 plus 150. So let me write it here. 50, 150. You get it? So totally, this is what we have now, and now we shall solve it. So 175 minus 150 by 100, 150 by 200, you solve it, you'll get 3 by 4. How n of b is 75? Oh, I'm sorry. I've added it. I'm extremely sorry. Totally, we had only 50 bolts. So this is total, right? Total. Totally 50 bolts only. Out of which 25 are rusted. Out of 150, 75 are rusted. Right. I made a mistake. I'm sorry. Totally 50 bolts are there, out of which 25 are rusted. Total number of rusted elements are 100. Number of A plus number of B minus number of A intersection B whole divided by total number of cases. So altogether it is 50, 125. 125, 50, it is in terms of 25 table, 5 times, 8 times. That's it. 5 by 8 is right answer. I'll tell you again. I'm sorry I made a mistake here. So now I corrected it. I'll tell you. Let's say A is number of rusted events. The A is rusted event. B is bolt, event bolt. And A union B, they asked you to find either rusted or bolt. Okay, so totally we have got 20 elements, out of which 50 are bolt and 25 are, sorry, 150 are nuts. Out of 50 bolts, 25 are rusted. Out of 150 nuts, 75 are rusted, half of them, right? So we need to find total number of rusted elements. 25 plus 75 altogether it is 100. 100 rusted elements are there and 50 bolts are there. In that bolts, 50 bolts, rusted as well as bolt, rusted as well as bolt, it is 25. Using the formula, I'm getting the answer. Okay. Could you get this? Any confusion on this? Similar to the first question, that multiple of 3, multiple of 5, no? Similar process. Okay, in that case, tell me the answer for 8th question. See, in probability, they've given you a simple equation kind of question. CSAT 2015. In a box of marbles, there are 3 less white marbles than red ones. 3 less white marbles than red ones. And 5 more white marbles than green ones. If there are total 10 white marbles, how many marbles are there in the box? Good question. They have twisted it. Twisted the scenarios. We'll solve it. Copy this faster. We shall go to the next question. Okay, shall we? Next question. Question number 8. What was the clue number 1? There are 3 less white marbles than the red ones. How many ever red marbles are there, 3 lesser will be number of white marbles. So number of white marbles is equal to red marbles minus 3. Can I tell? Can I tell? That's it. And then what's other clue? 5 more white marbles than the green ones. How many ever green marbles are there, plus 5 will be number of white marbles. So from this I can tell R is equal to W plus 3. Here R is green is equal to W minus 5. Why did I write these things in terms of white? Because they've given you the number of white, right? Totally 10 white marbles are there, right? They've given you white marbles is equal to 10. And then from this I can tell that red is equal to 13, because 10 plus 3, 13. And green is equal to 10 minus 5, 5. So totally how many marbles are there? W plus R plus G. That's what I want. Total number of marbles. So 10, 13, 23, 23 plus 5, 28. That's it. Simple, right? Straight away, equation kind of. And they might extend the question. In this case, what is the probability of getting red marbles? They might ask you. Here, tell me the answer. What is the probability of getting red marbles? My question. Probability of getting red marbles. They'll give you every data and they'll ask you like this, extension of this question. I'm asking, what is the probability of getting red marbles? By looking at the data itself, you can find the answer, no? Very good. 13 by 28. Total number of red marbles is 13, out of which in totally 28 marbles are there. Out of total number of events, favorable event. That's it. Favorable event. All right. We are done with this. 8th question. Okay. 9th question. Yeah, let's solve it. 9th question. A problem is given to 3 students whose chances of solving it are 1 by 2, 1 by 3 and 1 by 4. Okay. What is it probably that the problem is solved? See, in this case, problem is solved. They didn't tell you only one of them solved or 2 of them solved, all the 3 solved. They didn't tell you anything like that. So in that case, problem is solved. So in this case, we need to find the probability that problem is not solved. And the remaining part will be problem is solved. Correct? So in this case, I'll tell you, 9th question, they said problem is solved. For this case, whenever you get this question, this kind of question, okay, you'll have other 2 ideas, 2 questions like this also, I believe so. We'll check on it. Whenever you get such kind of questions, problem is solved, whereas conditions are not given. It can be 1% solved or 2% solved or all the 3 solved, whatever it is. In that case, first find the answer for, find the probability of problem not being solved. And the remaining part would be problem being solved. So let's say in the 9th question, X bar, problem not solved. Okay, so then problem solved. Okay, problem not solved. Problem not solved means probability of X bar. This means none of them solved the problem. That is probability that A didn't solve the problem. 1 minute. Probability that A didn't solve the problem, probability that B didn't solve the problem, and the probability that C didn't solve the problem. None of them solved the problem. Here, problem being solved by A will not affect the process of problem being solved by B. They are all independent. A will solve the problem, A will solve the problem on its own, B similarly, C similarly. Everybody will solve the problem by their own. They'll not relate to each other. Correct? So they are all independent. So probability that A will solve the problem is 1 by 2. A will not. They've given you like this. Probability of A 1 by 2. Probability of B 1 by 3. Probability of C 1 by 4. From this I can tell that probability of A bar 1 by 2. 1 minus 1 by 2. Probability of B bar 1 minus 1 by 3. 2 by 3. Probability of C bar 3 by 4. Right, I'm going to use it here. 1 by 2, 2 by 3, 3 by 4. So 3, 3, 2, 2 gets cancelled. 1 by 4 will be there. This 1 by 4 is the possibility that problem not at all solved. I want to find probability that the problem is being solved. 1 minus probability of X bar. That's it. The answer is 3 by 4. You understand? Very silly. Similar question like 16th one. Similar process. 16th one. The same process. 16th one. That's homework. 16th one is homework. And then anything else? Lion killing. Okay, that's the question for 16. That's homework. 32 women. Ties at home. Okay, so we shall solve the 10th question. Copy them faster. A bag contains 15 red balls, 20 black balls. Okay. Each ball is numbered either 1, 2 or 3. 20% of the black red balls are numbered 1, 40% numbered 3. Okay, similarly among the black balls, 45 number 2 and 30% number 3. A boy took a ball at random. He wins if the ball is red and the number 3, or if it is black and number 1 or 2. What are the chances of winning? Wow. So this is a proper data interpretation kind of question. Okay. They've given you plenty of data. From that, you need to find only one answer. So manipulating the data will take little more time, but finding the answer will not take more than 1 minute. I mean, not more than 1 minute, more than 30 seconds also. We'll deal with this. We'll solve it. Let's take 15 red balls, 20 black balls. I don't know, Charan. We'll check with that. 2 by 3, 3 by 5, and 5 by 8. 2 by 8, 1 by 4. Yes, right answer, Charan. For 16th question also, you will get the same answer, 3 by 4 as an answer. Okay, we'll deal with the 10th one now. There are 15 red balls, 20 black balls. So question 10, red balls, black balls. Red, black. Numbered 1, numbered 2, numbered 3. They are numbered. Okay, red ball is being numbered, blue ball is being, sorry, red ball and black ball. They are being numbered 1, 2 or 3. Among which the red balls, numbered, okay, 20% of the balls are numbered 1. Out of 15, totally 15 balls are there. Here totally 20 balls are there. So they've given you 20% of the red balls are numbered 1. What is 20% of 15? 20%, 20 by 100 of 15 or 1/5 of 15. It is 3. Correct? So 3 balls are numbered 1. You write it. And then 40% of numbered 3. So 20% is 3. 40% will be 6. No. Those 6 balls are numbered 3. Correct? Can you understand that? So out of 15, 20% is 3. 20 by 100 into 15. 40%, double of this. It will be 6. Okay. So 3 balls are numbered 1. Red color, 3 balls numbered 1. Red color, 6 balls numbered 3. Okay. And out of 15, 3 and 6 over, it will be 9 remaining. 9 or 6 remaining. So we are done with this first part. Second part, in the black balls, they told you like 45% are numbered 2. What is 45% of 20? 5 times it is 9. So 9 balls are numbered 2. And then 30% are numbered 3. 30% of 20. It has 0, 0, 0, 0 cut to 6. 6 number 2. So 9 plus 6 is 15. 15 out of 20, 15 over. Remaining will be 5. You get it? So could you understand this part? How did I get this? Okay. So this is the scenario I want. I'm sorry. You understand? So 15 red balls are there, 20 black balls are there, among which in the red balls 20% are number 1 balls. Okay, 40% are number 3 balls. Remaining will be number 2 balls. In the black ball, 45% are number 2 balls, 9. 30% are number 3 balls, 6. Remaining will be number 1 balls. The question given like this: he wins. A boy is taking a ball. He wins if the ball is red and numbered 3. It has to be red color, numbered 3. So my answer should be this one. My possibility of winning is these 6 values, or if it is black and numbered 1 or 2, it has to be numbered 1 or 2. So this one or that one or that one. Altogether, how many are there? 6 plus 5 plus 9. It will be 20. Yeah, 20 out of probability of winning. Out of totally how many balls? 15 plus 25. Totally 15 plus 20. 15 plus 20, 35 balls are there. Then it will be 4 by 7. That is my answer. Probability of the boy winning the game is 4 by 7. How? I've got the data. A boy is taking a ball at random. Picks a ball at random. He wins. If the ball is red red color numbered 3. So numbered 3 red color ball. 6 balls are there. Totally 35 balls are there, out of which I can select 6 balls. Also, I can select 5 balls or 9 balls. Also 9 balls, right? 6 balls, 5 balls, 9 balls. Altogether, I can take 15 balls. No, not 15. 20 balls. I can select 20 balls to win the game out of 35 balls. 20 by 35. That's how we get the answer. You understand? See, decoding this is very important. Once I get this, getting to this answer is quite silly, right? You understand? Superb. Let's go to next question. A bag has 2 balls, each of red, green, blue in color. 3 balls are drawn at random without replacement. Here comes without replacement. Whenever you deal with without replacement, you're going to deal with combination. What is the probability that there is no green ball in these two? Okay. Without replacement, there are no green ball in these two. So you're not going to take green ball. No. That's for the 12th question. 11th question, find the probability the balls all of different colors. 3 balls, different colors. Okay. So 11th question, let me solve them. Hope you have copied it here. Question 11. What are they? Red, green, blue. 2 to 2. Okay. Red 2, green 2, blue 2. I want to select the probability. Totally 6 balls are there. Okay. Out of 6 balls, you're going to select 3 balls. Whereas that is my possibility. Out of 6 balls, I'm going to select 3 balls. That is my total number of combination. Correct? Total number of sample space. So what is the question? Find the probability that the ball are from different colors. Each ball. Correct? So 3 balls are drawn at random. Out of 6, you are selecting 3 balls. Okay. Among which each ball should be different color. That means one red ball, one green ball, and one blue ball. One. Red ball and a green ball and a blue ball. And I need to multiply, no? So out of 2 red balls, I'm going to select 1 red ball. And out of 2 green balls, I'm going to select 1 green ball. And out of 2 blue balls, I'm going to select 1 blue ball. That's it. Straight away, you can get the answer. You understand? Totally 6 balls are there, out of which I'm going to select 3 balls. That's not a big deal. That is my sample space. And what is my favorable event? Each ball should be from different colors. From the first scenario, I'm going to select 1 ball from the red ball. Okay, out of 2, I'm going to select 1 ball. Here, 1 ball from the green, 1 ball from the blue. That's it. So what is 2C1? It is 2. What is 2C1? 2. 2C1, 2. Divided by 6C, 6C3, 6, 5, 4. Divided by 1, 2, 3. Yeah. So let me have it here. 1 into 2 into 3. You will get division here, no? I'll bring it here. Okay, 2 3s are 6. Done. 2 2s are 4. Done. So remaining will be 2 by 5. The answer will be 2 by 5. That is my probability. As simple as such. 2 by 5 in terms of decimal, it is 0.4. The question is given in terms of decimal, right? 0.4. That's it. 12th over, sorry, 11th over 12th. Okay. Next question. There are 4 red balls, 3 green balls, 2 blue balls in the box. If 2 balls are taken out from the box, one after other means without replacing. Okay, one after other without replacing. Then what is the probability that there are no green balls in these 2? That means you're going to select non-green ball. Correct? The statement says you're going to select non-green ball. Okay. Totally how many balls are there? 9 balls. That is my sample size. Out of 9 balls, I'm going to select 2 balls. 9C2. Okay. Here also I'm going to select 2 balls. Okay. Where here I am going to select only a non-green ball. How many non-green balls are there without this? 6. 6C2. That's it. This is my answer. This would give me the answer. 6 into 5 by 1 into 2. 9 into 8 by 1 into 2 by 1, 2. They'll get cancelled. So 6, 5, 9, 8. In terms of 3 table, 3 2s are 3 3s are this fellow, 4 times. Then 5 by 12. That's your answer. We have it. Yes. Option A. I'll tell you again. See, I'm going to select 2 balls, 2 non-green balls. Thereof no green ball. That's the question given. So out of total 9 balls, I have to select 2 balls. That is my sample space. Total possibility. Among which my favorable possibility is non-green ball. How many non-green balls are there? 9 green balls. 6. Out of 6, I have to select only 2. 2 non-green ball. 6C2 divided by 9C2. Solving them, I'm getting the answer 5 by 12. You understand? Any confusion in this? How did you know to use the combination for this type of problem? Good question. See, whenever you deal with without replacement, you have to deal with combination. I told you no, one after the other without replacement, everything mean the same. And I've given you the clue there. No repetition allowed, classical method. No repetition, combination method. You remember that? I've written somewhere else in the left hand side. That's it. That's how we solve it. And also remember, whenever you're going to select things, I'm going to select things, always you'll deal with combination. Probability is more related to combination, maximum, most of the questions. Okay, straight away you can think in terms of combination. Very simple. All right. Question 13. If you have any doubt in these questions, among the 12 questions, you can ask me. Why didn't we use combination for the problem 2? What was the problem 2? Problem 2. See, there you are finding the number of times. Correct? You're finding number of times. Minimum number of times. That is the worst case scenario possibility. That's different. This is different. This is you're finding the probability. There you're finding the minimum number of times. Number of times is completely different from probability. Correct? That's why. Super. Now we'll go to the question 13. From a pack of 52 cards, 2 cards are drawn at random. What is the probability that both the cards are being kings? Here, what is the question? 2 cards are drawn at random without replacement. So here by default, it is not by default without replacement. It has to be without replacement in the question. Okay, from a pack of 52 cards, 2 cards are drawn at random. They didn't tell you with replacement, without replacement. Okay, so maximum 99%. If they didn't give you anything, look at the question, observe the question, or observe the option. Okay, first we'll observe the question. You're taking 2 cards. You didn't replace it. You just took it and you just looking at it. You're just looking at it. So that means you're taking first card and you're taking second card and remaining cards are there. That means you didn't replace it. Right? This means without replacement. You think like that. Okay. So they didn't tell you even like 1 by 1. Out of 52, you're taking 2. That's it. Okay. So what is the probability that both the cards are being king? Very simple. Question 13. I want to select 2 cards out of 52 cards. Correct? That is my sample space. And from which I have to get only kings. Both of them should be king. How many kings are there? From the 4 designs, 4 kings. 4C2. That is my favorable event. No? What is favorable event? I want to take my favorite idea. Here the favorite idea is taking kings. How many kings are there first of all? There are 4 kings. See, if I want to select a particular term, I'll go with that term. I'll just think in that term, right? So here I have to think in terms of kings. Okay, I have to take kings. I have to take a card from king. 2 cards from the kings. How many kings are there? 4 kings. Out of which I have to select only 2 kings. 4C2. That is my favorable event. What is the total event? Totally 52 cards are there. I want to select 2 cards, 52C2. You understand? Any confusion on this? We'll solve it. We'll get the answer. So 4 into 3 by 1 into 2. divided by 52 into 53 by 1 into 2. So 1 2 gets cancelled. 4 4 into 13, this is your answer. 3 by something. Do we have 3 by something ending with 9? No. So we can even solve it. Can we? 353. Oh, I'm sorry, it is 51. Extremely sorry. I have to go reverse, right? 51. So this is for 17 times then. So 1 by 17, 17 times of 13. 17, 170, then 51, 2, 21. 1 by 2, 21. It is 51, yes, 52 into 51. All right, 13 over 14. A bag contains 4 red, 3 black balls. A second bag contains 2 red, 4 black balls. One bag is selected random. From the selected bag, one ball is drawn. Find the probability that the ball is red. Wow, that's amazing. See, it needs a lot of space. So we'll solve the question in the next page. Okay. Copy this faster. A box containing 10 balls. Okay. So let's solve 14th question. A bag contains 4 red balls, 3 black balls. Question 14. First bag. 4 red balls, 3 black balls. Second bag. 2 red balls, 4 black balls. 2 red balls, 4 black balls. Right? Right. One bag is selected at random. I can select either bag 1 or bag 2. Bag 1 or bag 2. Okay. In the bag 1, I am going to select a red ball. Correct? So what is my probability? Probability of red ball. This is my overall probability. See, there are two ideas, two cases. First case, I am selecting a bag 1. From the bag 1, I am selecting red ball. Or I am selecting a bag 2. From the bag 2, I am selecting red ball. Right? So first I have selected a bag 1. After selecting bag 1, I am selecting red ball from the bag 1. That means a conditional probability. We had no A by B, B by A, something like that. So first, I am going to select a bag 1 and I am going to select red ball from the bag 1. I have selected red bag 1 from which I am going to select red ball. I have already selected bag 1 from which I am going to select red ball. You understand? Similarly, probability of bag 2 from which I am going to select red ball from the bag 2. Okay. See how many bags are there? Totally 2 bags. Among the 2 bags, what is my probability of selecting one bag? Out of 2, 1, right? 2, 1 by 2. Red ball from the bag 1. Totally 7 balls are there, among which 4 balls are red. 4 by 7. This is one set plus 1 by 2 multiplied by this one. 2 by 6. Solving them, we get the answer. We will get you the answer. This is for 2 times. This is for 1 times. You will get 2 by 7 plus 1 by 6. Taking LCM, it will be 42. So 12 plus 7. 19 by 42. Option B, 19 by 42. You understand? I'll tell you again. I'm going to select 2 bags. Among the 2 bags, if I select the first bag, from the first bag, I'm going to select red bag. See, no need to use the formula also. You can straight away think. I'm going to select first bag. Let's say there are 2 possibilities. First bag and second bag. Okay. First bag selection is 1 by 2. From the first bag, and I select the first bag, and I'm going to select red ball. So red ball from the first bag. This is my first. Second, or bag, I can select bag 2 and red ball from the bag 2. Can you think like this? First bag and red ball from the first bag, or second bag and red ball from the second bag. Solving them, I'll get you the answer. Simple. No need to think in terms of formula also. Think straight away. You'll get the answer. In the examination, no need to think in terms of formula. Most probably. Okay. Wherever you need to use A or B, at least one, something like that, like 16th question. In that case, you think in terms of formula. Otherwise, you think classically. Just random thought will get you the answer. Okay, so 14th over, copy them. 15th, a box contains 10 bulbs, out of which just 3 are defective. So 7 good, 3 okay. All right, we shall solve it. Hope you've copied. Let's go to 15. A bag contains 10 bulbs, of which 3 are defective. So 7 good bulbs, 3 defective bulbs. If a random sample of 5 bulbs is drawn, find the probability that the sample contains exactly 1 defective bulb. So remaining will be good bulb out of 5, right? So I'm going to use that idea. So question 15, out of 10, good defective, 7 good, 3 defective. Probability. I am going to select 5 bulbs from the 10 bulbs. That is my total number of possibility, out of which I have to select only, I have to get only 1 defective bulb. So out of 3, I can select only 1 defective bulb, and remaining should be good bulb. 7C4, because totally 5 bulbs are there, out of which 1 should be defective, remaining 4 should be good, right? 7C4, out of 7, I can select any 4 good bulb, and out of 3, I can select any 1 defective bulb. Altogether, out of 10, I'm going to select all the 5 bulbs, right? So solving them will get you the answer. So we'll solve it. 7 into 6 into 5 into 4 by 1, 2, 3, 4. And 3C1 is 3 divided by 10C5. 10, 9, 8, 7, 6 by 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So 1, 2, 3, 4, 1, 2, 3, 4 gets cancelled. 5 is there. 5 2 times. Okay. So further, can I cut it? Yes, cut it. 6 is 6. 7 is 7. Then further, this is for 3 times. Okay, 5 4, so this is for 2 times. Anything else? Nothing. 5 by numerator only 5. In the denominator only 2 3 2. 2 2s are 4, 4 3s are 12. 5 by 12. Do we have it? Yes. Option C. Cancelling them out will get you the answer. Simple. Okay. All right. 16th, I said homework, and the answer was 3 by 4. We had it. 17th. We'll do one thing. I'll give you the clues of 17, 18, 19, 20. 20th I'll solve because that's a theoretical question. So 17, 18, 19, I'll give you the clues. You solve at home. You'll get the answer. Let's solve 20th then. So first we'll solve 17th one. From a group of 7 men and 4 women, a committee of 6 persons is formed. What is the probability that the committee will consist exactly 2 women? Good question. Hope you are done. In this question 15, we shall solve question 17. Men, women. How many men are there? 7 men, 4 women. 7 men are there, 4 women are there, out of which I need 6 persons. Only 2 women are there. So probability, totally 11 members are there. Out of 11 members, I'm going to select 6 members. Whereas I want only 2 members, 2 female. Okay, exactly 2 women. First, deal with the condition. Out of 4 women, I need to select only 2 women. And the remaining, out of 6, 2 women. Remaining will be men, right? 7C4. Solving them will get you the answer. Okay. So idea is quite simple. Out of 11 people, I'm going to select 6 people for a committee. In that 6 people, only 2 should be women. So 4C2 should be women possibility. Remaining would be men's possibility. Out of 7 men, I will select any 4 men. Solving them will get you the answer. Right? All right. This is multiplication. And then comes 18th question. A box of oranges is inspected by examining 3 randomly selected oranges without replacement. If all the 3 are good, then the box is approved for sale. Otherwise, is rejected. Find the probability that the box containing 15 oranges, out of which 3 are bad. So out of 15 oranges, good, bad, 3 bad, 12 good. Correct? Will be approved for sale. That is, see, out of 15 oranges, you are selecting 3 oranges. And it is approved for sale. What is the condition for being this box is approved for sale? Very simple. The box, if you select 3 oranges, all the 3 oranges should be good. See, in this box, we have got 3 defective oranges, but still the box is approved for sale. I want to find the probability. Out of 15 balls, say 15 oranges, I am going to select 3 oranges. Whereas the box is approved for sale. That means I have selected only good oranges. I didn't select bad oranges. Correct? Then only it is approved for sale. All the 3 must be good without replacement also. Out of 12, I am going to select only 3 good oranges. I don't want to worry about this. Anyway, it is 3C0. Leave them. So solving them will get your answer. Can you repeat the selection portion once again? Q15 less than 15. I'll tell you after we are done with this. Okay, we have got time, right? I'll tell you. 4C2 by 11C6. Where? There. Okay. For this question. And the remaining part, remaining men should be there. No, I'm selecting men and women also should. Sorry, I'm selecting women and men also should be there, right? That is also a possibility. We need to add them up. We need to multiply them also. Okay, 18th over, and Rubasti, I'll tell you that 15th question after we are done, ma. 19th. What is the probability of getting an odd number at least once when 3 unbiased dice are thrown? Okay, unbiased means it will give you equally likely events. Equally likely events means I'm throwing a die. I'll get 6 results, right? 1, 2, 3, 4, 5, 6. In 6 times, if I throw, I'm getting one number. Okay, 1, 2, 3, 4, 5, 6 in all the events. Okay, first event 1, second event 6, third event 5, fourth event 6. I'm sorry, 3, fifth event 2, and sixth event 4. For all the events, for all the 6 times, I'm getting different numbers. This means for every time I'm getting different number, and hence this is what, and this is called as equally likely. Every number will get a chance for every time I'm throwing a die. This is what we call equally likely event. This equally likely event is happening. No, that experiment is called as unbiased experiment, and I'm throwing an unbiased die. No, it gives equally likely events. Biased. Okay, it is not partial. Okay. 19th question. Odd number at least one when 3 unbiased dice are thrown. I'll tell you how to solve it. 3 unbiased dice are thrown. No. So question 19. Total number of sample space would be 6 cube. Correct? 216. 3 unbiased dice are thrown. At least once I'm getting odd number. Correct? So in that case, let's say let's find I'm getting even number in all the cases. So I'm going to throw 3 dice. 3 dice faces will look like this. In these dice I'm getting even number. If I find the probability of this and eliminate them, remaining would have at least one odd number in the face. Correct? I found all the even number possibilities. Eliminate them. Remaining would have at least one of them having odd number. Correct? So find the even number in cases. Okay. Probability of even number in all the cases. In the first 6 events, 3 events will be even number for the first die. Out of 6, 2, 4, 6 will be even number, and second 6, 3 events will be even number, and 3 events will be even number. So this will be 1 by 8 because 1 by 2, 1 by 2, 1 by 2. So 1 by 2, 1 by 2, 1 by 2, 1 by 8 will be the probability of getting an even number. Correct? In all the 3 phases. I don't want this to. Okay, I don't want this to. Anyhow, we'll have it for now. And then probability of at least one odd equals to 1 minus probability of all of them are even. 1 minus 1 by 8, it is 7 by 8. That's it. 7 by 8 is there? Yes, option C. I don't want this for the case of solution, right? So how do I do it? Out of all the events, I'm going to select certain events, whereas all of them are even. And finding the probability, eliminate them from the total probability. Total probability, eliminate them, you get the resulting value for the question. Correct? You understand? Because you need to get at least one of them should be odd number. So I got all the events to be even number, all the phase showing even number, and eliminated them. I've got the answer. Okay. And 20th sum. Last question for the day. A bag contains 5 red balls and some blue balls. So X blue balls, let's say. If the probability of drawing a blue ball from the bag is thrice that of drawing a red ball, then what is the number of blue balls in the bag? Okay, so let's solve it. 20th question. The answer is 15. Straight away we can find the answer, but I'll tell you how to find the answer. Shortcut also. Okay. Hope you're done. 19th, 20th. Number of blue balls, X. Number of red balls, it is 5. Total number of sample space. Total number of balls is 5 plus X. Correct? They said probability of selecting blue ball is equal to 3 times of probability of selecting red ball. That was the question. Probability of selecting blue ball is 3 times of probability of selecting red ball. What is probability of blue ball? X by 5 plus X. How? Probability of B is equal to number of B by number of S equals to 3 times of 5 by 5 plus X. Probability of red ball and number of red divided by number of sample space. 5 plus X gets cancelled. This implies X is equal to 3 times of 5, 15. Correct? Right. How do I define the shortcut? Very simple. Probability will ripple on the numbers, will ripple on the number of terms. Correct? Probability will be based on number of terms, number of favorable events. Correct? So leave the probability. They said number of selecting blue balls is equal to 3 times number of selecting red balls. I want to find the number of blue balls. Number of blue balls is equal to 3 times of 5, 15. Straight away you can get the answer. Shortcut. Provided you have only 2 set of numbers. Okay. Otherwise, you have to solve in this classical manner. Shortcut exclusively for this kind of question. Only 2 set of numbers, 2 set of colored balls and solving them. Okay. You understand? Probability is nothing but total number of possibility in the denominator and favorable event in the numerator. Okay. And one student, Rupashree, question 15, right? You asked. A box contains 10 bulbs, out of which 3 are defective. If a random sample of 5 bulbs are drawn, find the probability that the sample contains exactly 1 defective bulb. Okay. So we are done with this. If you have doubt, you retain and ask me. Otherwise, you're free to leave. Thank you so much. And Rupashree, let me explain. 15th question. See, totally we had 10 bulbs, out of which 7 are good, 3 are bad. Okay. 7 are good, 3 are bad. Here I want to select 5 bulbs. That is my total possibility. Out of all the bulbs, 5 bulbs I'm going to select 10C5. That is my sample space. Whereas What is the probability here? I mean, the favorable event here. Very simple. You need to select only one defective bulb. That means out of 5 bulbs, you need to select one defective bulb and remaining 4 should be good bulbs. This has to happen and good bulb has to happen. Okay, so 3C1, that is my bad bulb selection, and good bulb selection 7C4. Out of 7, I'm going to select only 4 bulbs, no, 7C4. And then all together solving them, I'm getting the answer. You understand, ma? Rupashri? Superb. Oh, that's Charan. Rupashri, understood, ma? Super, super, very good. So anything else, guys? If you have doubt, you can ask me. Otherwise, you're free to leave. 19th question, how come we take 3 by 6 and all of getting all even? Hemant, see, totally we have got 6 numbers in the first die. That's for first die. Leave this 6 events. I don't want this 3 events. Okay, 3 dice. I'm going to deal with only one die. Correct? First one die. First die. First die. Second dice and third die. Let's have it like this. In the first dice, you're getting even number. Out of 6 events, 6 possibilities, 1, 2, 3, 4, 5, 6. I'm going to have only 3 numbers, right? 2, 4, 6. That's how 3 out of 6. Similarly, 3 out of 6, 3 out of 6. All of them are even numbers. It can be like this: 2, 2, 2, or 4, 4, 4, or 6, 6, 6, or even 2, 4, 6, 4, 2, 4, 4, 2, 4, 6, 2, 4, 2. It goes on like this. Plenty of numbers goes on like this. Okay, this belongs to permutation. I don't want to deal with permutation. These are all the possibilities. How many possibilities could have happened? That's what they want, right? Out in the first die, out of 6 numbers, only 3 numbers are even numbers. That is my possibility. Favorable even for now, for the first die. Second die, similar process. Third die, same. So 3 by 6, 3 by 6, 3 by 6, 1 by 2, 1 by 2, 1 by 2, 1 by 8. That 1 by 8, no. 1 by 8 means out of 8 events, only one event will contain all the dice to be even numbers. And the remaining will be one odd number, at least one odd number. Yeah, superb, superb. Anything else, guys? Thank you, thank you. I'll wait for 1 minute. If you have doubt, you can ask me. Otherwise, we'll leave. Last question, shortcut again. Okay. See, number of possibility. Okay, I'll write it here. What is the probability of any event A? Number of A, number of B. The number of S. Probability of event B, number of A per number of B by number of S. Correct? So let's say probability of A equals to probability of B. Okay, so that is number of A by number of S equals to number of B equals number of S. This implies I can tell probability of certain events being equal will ripple on, or will give you the result on number of events. Correct? Probability of certain events being equal or being multiplied of something, multiples of something, whatever it is, will be responsible based on the numbers. Correct? That's how we get the shortcut. You got it, ma? Sharmista? Superb. That's how we get the result. That probability will result on the number of events. Similarly, vice versa. Number of events will result on the probability. Simple. Anything else? All right. We shall leave. Thank you, guys.
Recording stopped.